example, it improves the products and services. Because one incinerator maker, so just take one example, one simple component, incinerator. The owner wanted to know how the incinerator behaves in different sea conditions. So we have carried out a study, installed the necessary sensors, collected data, processed the big data, and fed it back to them, and based on which they improved the design. And they later told that their sales went up by 30%. So this is how big data can help you. And then, of course, it supports regulations. One regulation is the EU MRV regulations. I don't know whether you have heard about it. That is, you are measuring, reporting, and verifying the fuel consumption on board ships. And the EU MRV might be mandatory in the near future. So since we already have the data, we don't have to reinvent the wheel. We can just process the data, filter out what is necessary, and submit it. And most of all, we can streamline the surveys. When the surveyors go on board, when they see an equipment, once they have the big data result with them, just to let them know whether that particular equipment is running properly or not, whether to open it up or not, they can make a very informative conclusion about it. So that is what we are trying to use trying to use the results of the big data analysis. And finally, let me show you a video. It is the ship that I was mentioning. It has got some of the very technologies that has recently been developed.
It's starting, the Drive Green project. As a culmination of efforts to reduce impact on the environment, K-Line has launched the Drive Green project, integrating the cutting-edge technologies of domestic shipyards and ship equipment manufacturers. The construction of the world's highest standard, next-generation, environmentally friendly flagship, the Drive Green Highway, is now underway. As a result of simulations to strike a balance between the reduction of environmental impact through lower fuel consumption and the improvement of cargo carrying capacity, the Drive Green Highway has been designed to be a post-Panamax ship with a length of about 200 meters and a width of 37.5 meters. It has a carrying capacity of 7,500 passenger cars. Reduction of environmental impact is targeted at reducing sulfur oxides by over 90% and nitrogen oxides by over 50% compared to conventional ships. Moreover, along with achieving these aims, we are working for the reduction of carbon dioxide emissions by over 25% by improving fuel efficiency through various energy-saving technologies. These environmental measures will be compliant with the air pollutant emission regulations planned by the IMO, or International Maritime Organization, before they enter into force. The engine on board will significantly reduce nitrogen oxides by combining a water-emulsified fuel system that adds water to fuel and an exhaust gas recirculation unit that reuses some of the exhaust gas. In addition, through a device that automatically controls the efficient operation of the turbocharger to match the engine output, it becomes possible to comprehensively reduce nitrogen oxide and carbon dioxide emissions. The exhaust gas outlet is mounted with a unit to wash the sulfur oxides out of exhaust gases, called a scrubber. The scrubber takes advantage of the fact that sulfur oxides easily dissolve in water and removes the sulfur oxides in the exhaust gas using seawater or fresh water. Through this unit, the ship is able to comply with the sulfur oxide regulations of the IMO, and cost efficiency is also enhanced. Renewable energy is used as well. Over 900 solar panels line the top deck. The amount of power that can be generated makes this one of the world's largest solar power systems for ships. It generates enough electricity to power all lights on the car decks. The ship also has many other kinds of equipment to reduce environmental impact and save energy. Inverter control, which has a large energy-saving effect, is used for the draft fan and seawater pump. The heat of the exhaust gas from diesel-powered generators is also not wasted, but used effectively. Low-friction paint is used on the bottom of the ship to reduce friction drag. It effectively reduces fuel consumption by about 2 to 4% compared to conventional paint. A high-efficiency propeller is used to achieve energy savings of approximately 2%. Asymmetric fins are placed on both sides of the rudder to save fuel and raise speed. The streamlined, stylish design cuts wind resistance by about 20%. By introducing an optimal voyage support system to achieve low fuel consumption and optimal operations, carbon dioxide emissions can be reduced by about 3 to 5%. Together, these effects can achieve a reduction in carbon dioxide emissions of over 25%. Additionally, the large size of the ship will make it even more possible to meet diverse needs for transportation. Not only would it be able to transport passenger cars, but also roll-on, roll-off cargo, heavy construction machinery, and railway cars, among others. The world's first next-generation environmentally friendly flagship that integrates cutting-edge technologies, the Drive Green Highway. With the capacity to carry 7,500 cars, this ship will be launched in spring 2016. To achieve K-Line's Environmental Vision 2050, we will continue to take on advanced challenges and support the world's logistics infrastructure through transportation services that excel in energy efficiency.
As I mentioned, the first ship was delivered in February 2016, and the second ship was delivered late last year, and 6 other in the series are in the drawing stage or in the construction stage. They'll be coming out soon. And with this, I would like to conclude my presentation. And I think we will take the question and answers at the end of the panel discussion. Now, may I invite the second presenter, Marco, to deliver his presentation. Could you please upload it?
Okay.
Is it this one? Yeah. Okay.
And I might need the
Yes.
controller.
Yes.
Yes. Okay. These are exciting times in the maritime industry. We are talking about big data. We are talking about IoT. We are moving to even remote and autonomous vessels. We are really excited about it. But there is a but. The point is, are we really able to bring down to the details the business case? How can we really make sure that when our ship owners or ship management companies are investing in this technology, are they getting a return of investment? This technology is not for free. You have to install, we have seen, quite expensive component on board the vessel. We need a software IT infrastructure on board the vessel. We need a communication infrastructure. We need a service by the providers. They have to analyze the data. So it's not for free. So how we can make sure that our customers are getting a return of investment? So what I'm going to present today is a hint of how we can make money out of the data, how we can give a return of investment to our customer, how we can save and how much we can save with some of the data analytics. In Rolls-Royce, in Ship Intelligence, we have a division for remote and autonomous, and we have a division for intelligent asset management. In intelligent asset management, we look at both health management, so condition monitoring system of the equipment, and energy management, fleet management, and then business management. Today I want to present to you a bit of the energy management. And I will have to go through a couple of slides in which I will present a bit what is energy management. The purpose of energy management is reduction of fuel consumption. Okay? So how this works, we need to install some sensors on board. We can couple with practically any control system on board. And then we also install a computer, multiprocessor computer on board, and we link to your control system. And on board, the crew can actually access a graphical interface, which is very intuitive. They can see whether they are running better than expectation, better than certain standards, so they are in a green zone, or they're actually consuming more than what's expected, they are in a red zone. It's pretty much what you have on a dashboard of your car. You press the pedal, the throttle, and you can see how much you are consuming of fuel and whether you are in the economy zone or not. We also take some of this data. This is running independent on board. We take also some of this data, we send it on shore, and then we can present this data on a portal so that in the fleet management center of our customers, they can access the data of their fleet, and they can compare one vessel to another. They can actually see what the crew is doing, what the captain is doing. Very interesting. The point here is how much we can save with this. If we buy the equipment, if we buy the software, how much can we really save? Well, that's quite complicated to say, because if you take the example of the automotive industry, just by knowing that you are consuming this much and you are in the economy zone doesn't mean that you are actually saving. If you were an experienced driver who has been driving for 20 years and is driving soft on your pedal, by knowing that you are in economy, you are not saving much. Maybe you save 1, 2, 3, 4%. If you are a reckless driver and you know that you are not in the economy zone, but you are still not following the advice, you are still not saving anything. So it's actually very dependent on the crew experience and of the crew, let's say, willingness to follow the advisory system that is on board. So it's actually difficult to say, and we have experience of crews saving from 3, 4, 5% up to 15% of fuel saving. So what is then the real let's say, cost saving, the real fuel saving? Let's have a look at some charts here. So I will get in a very boring zone. I will show you some very boring chart, but I want to do it to make a point. When we get the data onshore, here is where we can really exploit the power that comes with the data. What you have here is a 1 year data of a vessel with, in this case, with the 2 engines. And what you have here is a chart of the specific fuel consumption against the power generated by the engines. You can see that obviously to have high power you need 2 engines. The curve on the right side is the curve with 2 engines. Then below a certain amount of power you can generate the same amount of power with 1 engine. What you can see immediately as an engine builder, you can see that the fuel consumption is higher where the power generated is, the specific consumption is higher when the power generator is lower. And this is very important because then what you can see here is that the customer here has been running quite an amount of time on 2 engines with a very high specific fuel consumption, where the crew could have actually run on 1 engine. And this graph is also very important to do another thing. So in another slide later. So what we can do here is actually Rolls-Royce, we can actually interact with your control system, and actually we can program the control system to give you an advice where you are in the zone where you actually can run on only one engine. So you start to do advice on the proportion configuration, not only showing you an element of green or red, you're in economy zone or not. Let's go on the next stage, advising on trim configuration. So here, for different C state, we can actually collect data for a certain amount of time. Usually the first 3, 4, 5 months after we have installed the software, we collect the data at different C states, and we set a baseline. And based on this baseline, we can actually run on real time on board the vessel, do a benchmark on how the crew is doing, how the vessel is doing against the setting. What is important here is that this benchmark, we do it at the beginning when we install the software on the vessel. We collect the data for 6 months, we set the baseline, and we benchmark runtime. After 1 year, where we have collected 1 year of data, and if you have been following the advice and trying to be on adjusting your trim, just try to be in the green zone, the economy zone, you actually can set a new baseline, which is better than the previous one. And then you continue now benchmarking on real time against the new baseline. So what we are introducing here is a continuous improvement of a green behavior using some of the features of this software. We are talking about hull painting. This is another chart giving you the added resistance because of the biological growth on the hull of the vessel. Here is again another 1 year of data. Tell you that in 1 year on this vessel we added the resistance up to about 6% of resistance, which means fuel consumption. Now, why these data are important? Because in the fleet management office, a superintendent can actually start to look at how much fuel they are consuming today in addition of what they could be consuming less if they were cleaning the hull. And they can actually make a calculation and say, okay, should I take the next charter for the next 6 months, or should I take the vessel now to clean the hull? So with this data, we have started to do now, moving from the fuel consumption on board to do asset management. We can actually start to use this data to plan the docking properly before taking a charter and actually bid properly on a charter on fuel consumption. We can collect a lot of data about where the vessel is going. Here you have a chart of a vessel. This is a cargo vessel going up and down the west coast of Norway. And we can do analysis of this actually are two cargo vessels, how they can compare in the same leg in terms of fuel consumption. And therefore, actually, we can benchmark two different crews. This is another interesting or boring chart, depending on the time of the day. This is a cargo vessel, and this is a frequency chart. So how much time this cargo vessel has spent with the end for each on the x-axis of value of the engine load. So this is a cargo vessel, so you can see they have spent, let's say, almost 70% of their time in a port, okay, or at port on maneuver or slow transit. Well, they have spent, let's say, only, so you see, this is the cargo vessel, so 30% of the time. While instead they are spending 20% of the time here on on fast transit. And this is actually what a cargo should do. So when they are on port, they are at port. The engines are very low load. Then they go full steam out of when they get out of the port to get from A to B. Well, if you remember the previous chart on the engine, well, then the engine is working actually very well in this case, because most of the time they are actually moving at very high power. So the specific fuel consumption is actually very low. So as long as they use the right propulsion configuration, they are actually consuming a small amount of fuel for their operation. Now we have taken the same engine on a PSV vessel. Now you can see how the proportion is actually the opposite. On a PSV vessel, the same engine is now running 70% of the time on DP mode, or very low transit, while the 30% of the time is actually doing almost spread between the 15% of the load up to 90%. And in this PSV vessel then, since they are working 70% of the time on low load, we are on the left side of that chart on specific fuel consumption. So the same engine on that cargo vessel, based on their operation, is actually performing very well. Here, the engine is actually in the zone where they are consuming, they have a very high specific fuel consumption. But not only that, because we, engine maker, we design our engines on a specific load configuration. So what happens is that for an engine, we design the entire also maintenance profile, the maintenance for that engine based on a certain operation profile. So, and when we design the engine to run 60, 70% of the time at 80% of the load, and then instead the engine is running like this means that this engine will require more maintenance. Most probably we have to change more often the filters or the injectors. But now that we have the data, what we can do as an engine maker, we can change the configuration of the engine, we can change the parameters of the engine so they can consume a bit less in this type of load. So we can actually now move into, again, looking at the asset management, because we can actually look at the cost of ownership of your engine. Not only the fuel consumption while you are running the engine, but actually impact your maintenance cost. We offer onboard capabilities that go through, analysis of real-time analysis of the fuel consumption. Then we go up to, a big cruise vessel. We can offer energy analysis, because then, the proportion is only a small portion of the entire energy produced by your power station. And on the portal, we offer then analysis of all aggregate analysis of your fleet and analysis of one vessel against the other vessel. Now, when we put all of this together, the onboard real-time fuel consumption awareness for the crew, plus all the analysis that we can do onshore as a service for the customer to advise on how to better change the configuration of their engine, how to better manage their maintenance, how to better manage their overall cost of ownership, then we can come up with a number. This is a customer, Golden Energy, who says that they have been saving for every day, for every charter, for every vessel, up to 2 cubic meters of fuel. You make the calculation, how much will then cost for you? Someone here, some smart guy here can tell me, okay, Marco, but this is an offshore vessel, so they don't pay for the fuel in a charter. Where is the business case there? Well, they don't pay for the fuel in their charter today, but they bid on a charter based on fuel consumption. So what happened is that they have a charter, They all bid and say, I'm going to use this much amount of fuel, I'm going to use this much amount of fuel, and so on. If they go beyond that amount of fuel, they pay a penalty. If they stay within that limit, nothing happens. But now that we have all the data, we can simulate your fuel consumption for your next charter. So we can help you to better place, market your vessel for that charter to your customer. So what we can do here is actually use the data not only to impact the bottom line, the cost, the operating cost, the fuel consumption, the maintenance cost, so the cost of ownership, but actually we can impact the top line, the profit. We can help you we can use the power of data to better market your vessel and get higher profit, higher revenue. So hopefully I make the case here of how we can use data, both from the data that we have only looked at the data of the operation, how we can use the data for operation to actually improve the profit by cutting the cost at the bottom line and increase the revenue at the top line. There are many other data that we can utilize to have a better picture. There are also condition monitoring data. I think that is going to be for another session. Thank you very much.
Thank you, Marco, for the fantastic presentation. Now may I request Piyush to continue with his presentation. This one, isn't it? Yeah. Okay.
Good afternoon, everyone. Thank you, Mastic, for inviting DNVGL and me to talk on this very pertinent topic. And my apologies to the panel and to all of you for my phone going off while sitting on the dais. Gives an idea how important these smart devices are to us, that we carry it every time we go, wherever we go. All right, coming back to the topic of the day, big data in maritime industry. In specific, I would be looking at how this has been used for day-to-day maritime operations, and we heard also from Dr. Rahim how the data platforms are coming in picture now, and we all hope that it is going to help all of us shape the industry in a better way. Just to take you a little back, mankind had changed, we all know. If you look at the first photograph, of course, we look very different now. We have been improving on technology, our knowledge, global markets. In use of energy and resources, we have been moving forward. And of course, we have been growing in number, posing bigger challenges, and on our way, innovating, discovering new things, moving forward. But what has happened to shipping? We are naval architects, quite a lot of us here. Not much has changed as far as physics is concerned. We're still talking about beams, long, slender objects which float on water. I'm sure not all of us agree with this. We have already seen that things are improving. Things are changing. The boundary conditions for where we operate, where we live, have been changing on every day. We have been making progress on technological front. We have been more aware of what we are doing to our environment. And in that process, at the shipping industry, we have been looking at things which are very pertinent to us, very pertinent to what we have been facing from day-to-day operational perspective. But somewhere in the background, and we must give that credit to the people who have been looking differently, who have been working diligently in collecting information from various sources. As you see, here, and coming up with answers which are not directly related to having delved into technology or having looked very closely into from the industry perspective. In around 2004-05, when this was first said by then CEO of Hewlett-Packard, not many of us in maritime industry really thought that it is going to impact us in the way it is impacting us now, and we are discussing it here. But this is true. We all know it. When this happened, as DNVGL, we went to our clients and, we started asking them, this was done in 2014 in a structured exercise. We asked if the big data is actually changing the way they work. And what we heard was surprising. We saw that a lot of what we experience in personal life is actually making slowly headways into our operational day-to-day life, and things are changing. People have been giving more and more emphasis on having data ownership, and it was believed that this provides them a competitive edge. We saw that the data is now becoming the raw material for taking decisions. It's not only what we have in terms of technology from other maritime stakeholders, but data in itself is something which can be synthesized and can be used for decision making. Data security was top on the agenda, and we had a general feeling that out of this exercise, the winners would be those who would not look at incrementally changing things, but taking bold decisions for a disruptive change. So in the initial years, the credit of entering into big data goes to people who have been collecting data from human behavior, geospatial data, and contributory data coming from transactions from various sources. And from there, characteristics of big data like volume, the veracity, which is coming in real time, the variety and the truthfulness of it came into our notice. And then as the capabilities were built, values for businesses were built. So we must go back and say thank you to these guys who initially have, in terms of health diagnosis and logistics chain and targeted marketing, started using big data for decision making. We, since then, have been seeing how data has been increasing in volume, how Internet of Things have been helping equipments and machines becoming smart, the connectivity where not only peoples are connected, but things and machines are getting connected. We all know the computing power has been defined by the Moore's law, doubling in capability every second year, and that's still a few years before it can subside. So what we have in front of us is opportunity and the challenge which is coming from the data which is all around us. As we speak, in maritime industry as well, we are not so far. We heard already from Dr. Rahim that the data coming from ships is now not in terms of kilobytes or megabytes, but in gigabytes. These are not also dependent on, say, internet to transport the information, but these are IoTs which are able to transmit data by itself. And we see that as we go ahead, we would have approximately 35 terabytes of data to handle on a per day basis by 2020. Now, what all does it mean for the NVGL and for our customers who have been trusting in us and who have been trusting in collecting this data for their decision making? One big example is that the world's largest performance management community now meets at a DNVGL solution, which is called Eco Insight, where industry data, which is coming from AIS, from fuel, from various vessels, the weather data, which is coming from the satellites, these are providing an outside-in information to the data which is already coming from the fleet for a company. And then it is possible for the customers to look at where their ships are performing vis-a-vis peers in the industry and vis-a-vis their own benchmarks, which could be either from the sea trial data or could be from, say, the last dry dock conditions. And this is also allowing a 24/7 access anytime, anywhere, without any special requirements. So things are now very different from what it was, say, 10 years back. Now, it's also possible to look into more detail what was difficult a few years back in identifying the true propeller and hull performance. We touched this point in the previous presentation, where you get empirical data and information coming from the sea trial, and now it is possible to integrate the weather data coming inside your current operating condition and bring that to the calm weather condition and see that on a daily basis what is the true performance of your propeller and hull. And this, in turn is helping the customers to identify which are the worst performing vessels. They can investigate reasons, whether it is speed variation or bad hull condition or any other ancillary equipment performing not up to the mark. And similarly, there are several other data smart services available which could be highlighted, which was not possible earlier. Now it is possible to have, for example, a model-based approval where most of the calculations could be run onto a digital model, and basis that substantial less amount is required for, say, a surveyor to do actual physical inspection. And that goes also when the vessel is operating for the surveys. The whole idea of having, say, a digital model right from the design stage up to the time the vessel is scrapped, the digital twin, is helping not only us, but also other stakeholders, designers, equipment makers, to simulate things and see how they can make things more efficient for day-to-day uses. But as we move on, we saw that data has been captured, data is being sent to a data center, is being utilized for analysis, and decision making is getting based on that. Is that all what is possible with data? What we believe is that we are just starting to understand what we can do with the amount of information which is coming to us from equipment makers, from ship operators, and from various other sources. And that is where comes what we say Veracity, which is an open data platform. And unlike a platform where data is collected from many to one kind of source, this is a many to many data platform. What it fundamentally means is that you have producers. These are stakeholders who provide data. It could be either in the context of value creation, so that it could be known report, it could be information which is coming and creating the value on its own, or it could be a data which is purchased, which is coming from other sources, but it makes sense for some decision making for the stakeholders. And then on the other side, you have consumers which are using the content to create value either for themselves or for anybody else. So this kind of a setup allows many to interact freely with many around, say, a set defined purpose and objectives. Gone are the days when the winner takes all kind of philosophy is going to work. This is going to be a very collaborative environment because things are going to be more and more specific. We have equipment makers who can do things more diligently and more effectively on the things which they are operating. We have designers who have been working for quite some time on design, and they can come up with ideas, with thoughts which are very specific to the competencies they bring. So the idea of a data platform where many interact with many and create solutions which is going to help decision making is perhaps what we are looking ahead in future. Veracity, which was launched recently, works on the same platform where we have, as of now, primarily DNVGL putting in the data and some pilot customers, as of now, putting data from other sources. Now, this is the same platform which is being used by DNVGL and by other industry players. It's an open platform. The idea of creating such platform is that once the data comes onto the platform, it is cleaned and it is available for usage for anybody who wants to use it either for his own purpose or for creating a solution for the larger maritime industry. The benefit it brings to all of us here is it's an open source. It's scalable, so it can start with, say, a specific data application which is currently meaningful to you, but it allows you to build on subsequently where you can add more data sets and utilize it in various ways for either your own usage or for the usage of your own clients. The other thing, what it brings in is it's not only a data platform for maritime industry. It allows other industry players from oil and gas, from energy, and various customers who are in the maritime domain to come and share the information. They are free to come and share their own information as well as take inputs from available data sets from shipping companies, from AIS, from weather data, and then use that for decision making. Now, the benefits, clearly there is a shared larger pool of people working together, so cost is minimized. You have better insights. You can run analytics. You can use companies which are really efficient in running analytics to provide solutions. You have availability of information from various sources, so you can validate information and that reduces friction. You can benchmark your own operations vis-a-vis peers in the industry and across other industries as well. So there is a lot of information and benefits associated with it when you start doing a many-to-many platform relation. Very briefly, these are the building blocks for Veracity. So at the front end, you have a marketplace. You can think of it very similar to an app store, which you have on your phone, which will have a product catalog. And here the solutions would not only be from DNVGL, but from any of you who would have a product which can be useful to any other maritime stakeholder. And that would be built on a Veracity technical platform, which will have a data lake, combining the business partners. And then there will be a digital engagement for the customers who can come to MyDNVGL and use the solutions in a similar way you use apps today. And then, of course, the other two blocks are for the creating commercial contracts, ensuring that you are able to generate revenue in a manner of what you contribute and what you take out, and a finance and accounting module to take care of the invoicing and taxation. This has value propositions for business-to-business data collaboration. Of course, software as a service, which we saw many examples already. It can provide insights. You can create queryable BIs and reports. And of course, traditional software products, documentation report, training, and so on. There are several other possibilities. You can visit the website and see what all it can do for your business. We are already at DNVGL using it for providing the next generation survey bookings where we are providing our owners on a push basis, suggesting them what is the best place to do a survey so as to reduce the cost and time. And similarly for other applications in our classification business, also data-enabled services for performance management, for security applications, and so on. So to end, this is a very old saying, 6th century BC, but still valid. We believe that opportunities multiply as they are seized. I hope that in coming years, as the data platforms and the data becomes more and more freely available to everyone, overall as a maritime industry, we stand to gain. Thank you very much.
Thank you for the excellent presentation. Now may I request the next panelist, York North, Vice President of United Arab Shipping Company, to give his thoughts on that.
Ladies and gentlemen, thank you very much. I have no presentation, so but at first, so we learned a lot, and I got a kind request from this Mastec to talk about a little bit about the user understanding about big data. And as you learned already, I'm working for United Arab Shipping. We are one of the biggest container companies, shipping companies here in this region. And we have delivered in the last years the biggest container worlds, like 20,000, 50,000 toy vessels. And what I like to say is we are really technology-wise on the highest standard. What does it mean? We are receiving every day tons of data to our vessel, and we deliver every day tons of data to different customer, partners, suppliers, our own organization. This we have to handle, that we're doing with 22 people on board, or 24 people partly, and that we are not educated IT specialists. We are engineers, nautical officers, we are standard professionals. What does it mean for us? We are today able, with a 20,000 toy vessel, to run it fully automatically. I can take my iPhone now, connect me to the vessel, I can connect me to the CCTV system, I can see what has happened on the bridge, what has happened in the engine room, I can connect me to the automation system to see every parameter of the main engine, every parameter of the auxiliary engines, or the additional supply on board and equipment. That is possible. We can do it, not only me, but my colleagues as a superintendent, technical manager, we can do exactly the same. That is one part. This is a big advantage, yes. But this advantage means in case we have damages, in case we have faults on board, that we can react faster because every minute costs money. And it's not necessary, we don't forget what is our main purpose, what we are doing. We are carrying container as a cargo from port A to port B, no more. And the target is to do it most efficiently as possible. And we're using whatever it's available on the market. And that it's, for example, that the technology processes are increasing in the last 40 years dramatically. We have today, what I said, waste heat recovering systems on board. Whatever we can use as energy, we try to use it. If I compare a 13,000 toy vessel built in 2012 in my previous company, today with a 15,000 toy vessel delivered last year, we had on the older vessel, 5 years old, a daily fuel consumption with 25 knots of 272 tons. Today, a 20,000 toy vessel has a daily fuel consumption with 22 knots of 170 tons only. In the operational speed for the 16 to 18 knots, we have a consumption of about 80 to 90 tons. And that means it's not only saving money, it is also saving the environment because the CO2 emission is much more less as it was before. How we are able to do it? We have the best technology for high performance, and that's what I'm coming to the big data. We have today hull sensors in every place of the vessel. We have hull stress monitoring sensors on board that we can see or in every second, how is the stress moment of our vessel, especially is it fully loaded, 400 meter long, 65 meter wide, that in heavy sea, that the captain on board and they can react immediately if we have too much stress to the vessel. But also, we want to have a long life vessel, not only 12 years. We build the vessel today for 20 years about. So therefore, we need all these sensors. So we don't, what's the high stress sensor? Okay. When we have the data from the main engine and our automation process, we are collecting and sending to a provider, in this case is Marorka, and he doing a totally analysis in every 15 seconds about our performance. We have a performance monitoring center in our company. It's the same pictures as we have a huge, let me say, a screening wall. We have it on board, and we got advices and hints how we can improve our energy performance. That is only possible that we deliver really all the time data. Maybe you have a question how we do it. So we have the VSAT systems on board. We have a good provider. We have a flat rate. And we're using this internet connection as it is, partly, also to 70% only for business and 30% for the crew. That is, I don't like to forget it, the crew is the most important part on our vessel because we are far away from their families, and today we have access via the all social media, Twitter, Facebook, whatever you call it, email. We can have a daily contact to the families. The whole vessel is in wireless LAN, so that we get from every point of the vessel that we get the data, and we have access to the data. One of the major items as well is it's not only that you're looking for energy performance of the engine and from the supplier and the equipment. The most important, what we see in a moment, is a voyage planning. That we have all the data what we received and all analyzes what we received from different suppliers, like for energy performances and so on, will be collected in this department, and they do a voyage planning from A to B. That it's the most important to know that you go with the most effective speed from, let me say, from Shanghai to Singapore, because you have the data when the vessel should be arrived, when is the terminal available, how long time we have to stay in a terminal, how many gantries we get, when we have to leave the terminal. So, and with this data, we make an analysis about our voyages, and we give a clear advice to our crew on board with how much speed we have to run, what is the trim we have to run. And that is only possible as we have received this available, all the data for our vessel and the analysis behind. One major item what I'd like to mention here is as well is who is the owner of the data. That is a big point today in the discussion. A lot of the data will be delivered automatically from the equipment. We are all equipped with, sensors, chips. We are direct connected to our satellite system. We deliver the data to the supplier, to special companies who do analysis for us. But the main question for us is who is the owner of the data, because it's not only the question about cybercrime. I see it more in the cargo side as on the ship operation side in a moment, especially for merchant vessel. I don't like to like to see a picture like for a cruise vessel. Maybe is a little bit different. But let me say so. If you drive with your car, you have a GPS, so you trust the GPS most probably. I do it. So I follow the voice and I go for the direction. A little bit check left and right, that is more or less right. But what would happen if your GPS in the car give you a way where you most probably ended up with an accident? Today on board we have active system, no shard system, paper shards anymore. We have a digital radar, all collected via the internet, that we have access, other people have access, and the people trust the system. What has happened in case that this data failed and the vessel going wrong? That means grounding, collision, whatever is possible. It was possible already. We had it in the company as well. So that is I like to mention here that is a point of discussion where we have also to look in the future with the safety of the data and the ownership of the data, because insurances and other parties we claim the money, and somebody have to pay the money, and that is always a big discussion. Let me say very simple: who is guilty? Not to make it too long. Today we are no more able to let run the vessel without all the newest technology in the world, because it's the most efficient to let them run. That is the best. We got the best analysis. We have the best support from everybody, like classification, supplier, management systems. However, we need, let me say so, we need association, a group, how to make some ideas how we save the data, and who is the owner of the data, and how we can use the data in the right way, and not as we learned, we have a lot of open platforms. Everybody collects the data, and nobody has an idea what will be happen and who will be use the data for the future. That is what I like to mention here, and we are already a little bit late. But anyway, if you have questions, yeah, please do it.
Thank you for the excellent analysis. So please give a big hand to my fellow panelists. Okay, now the floor is open for questions and answers, and we'll be giving the answers, and audience can also, you can chip in with your comments or answers. So the floor is open. Yes, please. Can I have a microphone there, please? One microphone here. Yes.
Hi, thank you very much for the excellent presentations. Myself, Hasi from ABS. So I just want to ask you, now that we are talking about terabytes of data transmitted between the ship to the shore and various storage locations. So what are the preventive measures we have been implemented to ensure that some people are not actually hacking the system or stealing away these informations, and rather misusing or giving some false comments which will trigger any problem for the machinery itself, and some sort of any cyber security sort of measures or guidelines or has been established so far?
Okay, thank you very much. Before I invite the opinion of the panelists, I can say yes, BIMCO is developing a cybersecurity scheme. In Class and Case also participating, and the U.S. Coast Guard is also participating. So it is in place. Now let me get to my panelists to give their opinion.
Yes. I will answer. In your question is a very interesting question. There are actually two questions. One is what are we doing in terms of technology, and the other one is actually what we can do in marine. Remember, the marine business is the last one who is getting on board on digitalization. In aerospace, we have been sending data from an airplane down to the operation center for years. We, Rolls-Royce, have been collecting data from airplanes every second from the last 12 years. And still yet, nobody has managed to hack and take control on an aerospace engine. So the technology is available. There is also another element, and this is what we are talking about here. Here we are talking about getting the data out of the vessel more than getting data in the vessel. So as long as we are talking about asset management or condition data or energy data, we are taking data out of the vessel. So today we are using one-way routers to get the data out and avoid any hacker to get in and take control of the lower level of the control system. There is the question becomes more interesting when we move into the remote and autonomous control. And again, the technology is there. In the aerospace industry, in the defense aerospace, we are running drones, and yet it's difficult to hack a drone and take control of a drone. So the technology is there. The question would be how we bring this technology marine and how we manage with the different insurance and classification society. For one last point is the amount of data. What we have been discussing here is a continuous sending data from the vessel onshore. That's not the future. The future is edge computing. The future is towards remote and autonomous. The vessel has a controls. The vessel takes decision remotely, and sending data only in the event of, let's say, something going wrong. So remember, we need to move from the standard type of data analysis in which we take a huge amount of data and we just look at the data onshore to machine learning and artificial intelligence, where the data are collected and analyzed there where things happen, and only in case an anomaly is detected, we send the data. Because with the amount of data that we are collecting every day, we will saturate any VSAT or Inmarsat.
Yes, I think that's a very good point, because when we have terabytes of data coming in, when in between there is a very genuine problem, people tend to overlook that. People just tend to think that it could be just a part of a big thing. Or
I've not been talking today of the future technology. I wanted to give today a hint of what we can do today, but we are not the only one. The future is not sending tons of terabyte from the vessel on. That's not the future. The future is a vessel, a brain on board the vessel that can collect the data, analyze the data on board real time.
Next, please. Your comment.
Just to completely agree with Marco, that's where the technology is. And it's not that when a decision has to be taken, all data has to come. That is where a normal data, what you use on the PC, differentiates from, say, big data. To use the data, you just send a query file and take what you need to use, and that's how the future is going to be. Now, to answer your question, what is being done currently, Class D NVGL has a recommended practice for data already published, and as an entity, you can go to My DNVGL. There's a free of cost application where you can go and check if you have a cybersecurity issue and if you would like to have an advice on that. So it's available as a class society. We are offering this service. You can go to the website and can have a look how this is made secure. One of the key things, as Jorge mentioned as well, when this data is collected, the first thing perhaps is that how to make it secure and how to make it of good quality so that it can be used. So these are the only two things which, as a class society, we are trying to secure, and the help is available on this. You can get in touch with us.
Yeah. Now that we are talking about the one-way communication between the vessel to the shore or to the management office, so in the future maybe we will be establishing a two-way communication. Like we'll be able to give some instructions from shore to the vessel to give to do some automatic repairs. But this is where the problem of the cybersecurity comes in. If somebody can hack this system, so he can send in the wrong messages, so it could trigger,
Yeah, absolutely. As I told you, the problem of hacking is not a real threat actually right now, because right now we send data from the vessel onshore and we look at the aggregate data onshore. So it's more of the veracity of how valid are the data we get from the vessel. So the threat is a threat, but the impact of the threat is not as big as it will be when we talk about remote and autonomous vessels. And what I'm telling you is that the technology exists today, and it exists in aerospace. And remember, we are only even beyond, even ahead of aerospace is the automotive industry. You can drive your Tesla now, and the Tesla takes completely autonomous decision and doesn't send any data, and only a few amount of data are sent for learning and teaching of the algorithm. And then the connection becomes two-way when there is a deployment back of the models on board the car. So again, the future will require, it has to be with less data going both ways,
And the future will be more and more on decision-making on board the vessel to avoid the source of the problem, which is the two ways, the return from shore to vessel. So the technology exists now, and we just have to learn from other industries, aerospace and automotive.
Okay, thank you. So we have listened to the class society, the equipment maker. Can I get the opinion of the ship owner, how they are dealing with the cybersecurity issue?
Actually, we face only one problem, and that's it's on the cargo side, on the container. Nobody's interested to hack our system on board, so I maybe a little bit blind, but I would see for the next years will be not so much a problem. But what we see is that we're hacking the cargo list, that we know if you have a 20,000 toy container or a 20,000 container on board, we know in which container are the computer from Dell, for example, and when we discharge the container in a different port as a final port. So that we had already learned from other customers and from other shipping industry, that was already happened. And we had also on one of our vessels a case that we know on which container are the smartphones, and we open up in one of the ports, we open up the container and stolen the try to steal the smartphones out. And this is only possible if you hack into the system and you get the information in which container the cargo is accommodated. So that is the only one what we see in the moment. Let me say, it's not a direct cyber crime, but it's part of it, because if you have such a big amount of container, you only can find it out if you know what is in a manifest of cargo, that you can see which cargo is in a container. Otherwise, you have no chance.
Thank you very much. Any other questions?
Just one thing.
Please give others chance. Yes.
It's actually it's a very interesting topic, actually, big data. So it's all the presentations were extremely good. I like to raise a concern actually here, because we spoke about big data, data analysis, data management, protection of data, all those things which we discussed. But my concern is actually Rolls-Royce, they have their own techniques on data management systems. DNV has their own guidelines. ABS, they may have their own techniques on the data management. But do you feel the requirement of do you feel the requirement of some guidelines? We can call it some sort of rules and regulations, maybe an IMO initiative, to collect this together and go in one direction. Because down the line, maybe after 5 to 10 years, everybody will develop their own data management system, and it will be a difficult situation to control at that time. So my views is like a common body like IMO, if there is a possibility, IMO to come forward and do some development in that respect. That's one of the concerns which I have.
Okay. Thank you very much. Now, I can answer this one. Of course, regulations does not come overnight. It has to be slowly developed. And at International Standards Organization, ISO, we are addressing this problem. And the one is ISO CD 19848. That's the standard data for shipboard machinery and equipment. That's already there. Then we are doing the new IHO S100 series that is being developed. And I think it's currently at the draft stage, the working draft stage. So it is likely to be in place by 2019. So people are addressing it. And as I mentioned, it takes time. So as the industry develops, so the standards will also evolve. But this is ISO standard. Then as for classification, now each class society has their own thing. At present, the data can be sent in any format, because finally what matters is that goes out, the result goes out. That can be standardized in different application protocol interfaces, and that process is ongoing. Okay? Any others?
I have a question for UASC on the big data, and you've just explained about the app that you have probably on your mobile, and you can see so much data. I assume the superintendents in the office probably have something similar. Isn't this changing the culture of the whole shipping industries in terms of the operation and the maintenance on boards? If we go back a long time ago, before the email was introduced, the ships used to send telex or whatever, and then there was almost no interference on board the vessel. We had capable people on board the ship who took care of the vessel. Then the email came in, And now the captains on board and chief, they're complaining of so many emails they're receiving because they're either emails that are directed at them or they're CC'd into it. So there's so much information. Now with the superintendents having the access to the vessel on hand, isn't that even might add more interference where the superintendent will look at a specific parameter, he'll pick up the telephone and call the ship, you have this problem. So how are you dealing with this?
It's a kind of philosophy, let me say so. We are able to see the data, and we can, as our offices, the technical manager, are able to connect to the vessel. Due to the international rules and regulation, the responsibility for every decision on board is in the hand of the captain of the vessel and the crew. If you start as a technical manager to watching every day full time all parameter on board and start to give advice to the chief engineer or to the captain, so go this way or do go, that you take over the command, you take over the responsibility, and in case of any injury or whatever, if the vessel damages, the insurance will immediately ask who did the decision. So, and the master is responsible for the decision. What we are doing with this, we are analyzing the situation on board, the performance on board, and we give hints and we give some recommendation to the crew on board how to can have a better performance, or we can see what is maintenance lack. That, for example, we have the maintenance controlling systems on board. What we have to do, that is done, and we are regularly visiting the vessel. But to take over the command from the captain to a land-based operation, no, it's not possible in a moment. It's, technically wise, yes, but from the insurance point and from the responsibility, and it's not possible, and we don't do it.
Thank you. I think we are really running short of time, so any other
last question?
Yes, please.
We were talking about the prospect side of the data collection, and in fact, it is going to be taking the entire. The data as it'll help people from the source to the end user directly. So there are a lot of middle players are going to come in the way. Have you ever thought of the consequences of this particular gathering of data, and is it going to be impacting the future, the other industries or the middle players?
Yes, I think in other industries they are playing it really well. So maritime industries also has to develop this. May I request the panelists to give their shot on that.
Allow me to give a couple of examples from other industries. What has been bringing digitalization in the automotive industry? Now we have autonomous car, and it's going to completely change the way it's working with the car business. So think about Uber today or Tesla. What Uber will do one day, they will just put a carpool of cars in the center of your town. You will have your app. Your daughter, without driving license, will take the app, will say to a car, come and pick me up, and will use your credit card, Papa credit card, to pay to bring her to the gym. All Avis or all the car renters, they will be out of business. So what is important to understand is that digitalization, we are on a journey right now. We are at the first step of digitalization. And we need to think about take care of that anymore. The risk is transferred. And then the next level, what is happening today, what is going to happen very closely to the automotive industry, the operation itself is transferred. It's transferred to an autonomous vessel. So that then the fleet management companies can actually focus on the cargo movement. So this is happening as we speak. For instance, in big companies like Amazon, they have now complete overview and ownership of the supply chain. And they have even taken over the fleet management companies, deciding how to move the cargo and what to load on which cargo. So again, when we talk about digitalization, what is the impact? Let's not focus on today, because today is the first step. The future is completely different. And we need to understand that. I told the same thing a few months ago in in this forum in Dubai, most probably a good portion of we sit in this room are not going to be there in 10 years from now, like most of the companies renting car right now, because the business model is changing. And we need to understand how it's changing and change our own business models to cope with that.
Thank you very much. And so now I think we are standing between you and the lunch. So we don't want to eat into that one. So may I hand over to Shaji to continue with this. Thank you.
Thank you very much, all of you, Dr. Rahim, Mr. Marco, Mr. George, and Dr. Piyush. It was indeed a knowledge sharing. Profound knowledge has been shared with us. We thank you so much for the information being shared. Before we just wind up for the lunch, we have the time for giving our token of appreciation to the people who are presented us with this profound information. May I request Mr. Joe Bringat, the Vice President of ABS Middle East, to come on the stage to give away our token of appreciation. Our moderator, Dr. Abdul Rahim. Mr. Marco Cristoforo Camparilla. Dr. Piyush Raj. It's very easy. Mr. Yorg Nutt. We will have a group photo as well before we leave. Thank you, Mr. Joe. It's time for the lunch break. A sumptuous lunch has been kept outside the foyer, outside this hall. You may please go ahead and have your lunch, and we will be coming back. Please come back at 2 o'clock. We'll be starting our program at 1:55. We will start at 2. You may be entering to the hall at 1:55. Thank you so much.
Integrated global market. Supply chain system optimization is the key to increase company competitiveness. Now, we take a big stride forward with one-stop solution based on the worldwide global network and a cutting-edge system. The global SCM innovator, CJ Logistics. CJ, a global lifestyle company, leads the lifestyle of people all over the world. Food and food service. Bio and pharma. logistics and retail, and entertainment and media. CJ Group creates the culture of cosmopolitan people in 4 major areas. CJ Logistics, the key engine of CJ Group and the leader of global logistics innovation, takes the lead with our customers at all times. With countries including the US, China, and Southeast Asia. Our logistical territory further expands with its worldwide network. CJ Logistics, with its TES-based advanced logistics technology, rich know-how on supply chain operation, and IT solution, has established one-stop logistics service optimized for each customer. TES, the key competence of CJ Logistics, quickly responds to the changing logistics market to create the new logistics paradigm. State-of-the-art and future logistics technologies such as convergence robotics and intelligence technology. Engineering that optimizes for the entire supply chain. System and solution based on IoT technology. Smart technology and consulting with expertise, presenting an optimized solution for customers in various sectors. This is the globally recognized competitiveness of CJ Logistics. CJ Logistics established a one-stop solution for the entire logistics field. Industry group-specific sales know-how and cutting-edge IT solutions. Total service of contract logistics. Based on the huge-scale domestic, overseas infrastructure and directly operated system, stable services are provided. #1 market share and customer satisfaction in South Korea. The company realizes #1 parcel service. From imports and exports of marine air transportation to customer clearance and storage. With diverse stevedoring equipment and facilities, CJ Logistics provides optimal marine cargo stevedoring and transportation service. Based on diverse EPC equipment and transportation know-how, CJ Logistics Project Logistics provides a stable logistics service for domestic, overseas plant, special, and break bulk cargoes. CJ Logistics always stays as a reliable global partner to customers. CJ Logistics has the whole world as a stage. CJ Logistics is broadening its market across the world with a global logistical network. Our one-stop solution will always be with customers.
We are the best, CJ.
The global SCM innovator, CJ Logistics.
Blue Water Shipping is a worldwide specialist in project freight forwarding, and with more than 40 years of experience, Blue Water is the right team for any major project transport. The job in this project, to transport a massive lower hull and heavy topside components for a drilling rig from Asia to South America. The company's Singapore office is in charge of the challenging project that involves strong teamwork with the client, external partners, and other Blue Water offices.
Out here we are not only a freight forwarder, we are a very dedicated project freight forwarder that likes to handle complicated stuff. We did the groundwork for this project approximately 2 years ago, and we did a lot of studies back and forth, not only on a commercial level but also on an engineering level, because the cargo specifications are obviously very complex, and we have to be very thorough and have to provide our client with proper solutions.
The debut of the project brings us to Batangas, Philippines. It's here where today the future oil rig's massive pontoons will be loaded. Blue Water Shipping is responsible for the complete wet towage from the yard onto the semi-submersible vessel and the delivery of the pontoons to Singapore. Carefully, the tugs maneuver the steel colossus above the deck of the Casco XRK. Once in place, the water is blasted out of the ship's 61 ballast tanks, and both pontoons rest safely on the dry floor. The ship now sets sail to Singapore to deliver its expected cargo. The first stage of the project is successfully accomplished. The two pontoons will now be used to create the lower hull, the massive base structure that the future oil rig will be sitting on. 4 special tugs connect their pulling lines to the lower hull. The Blue Water team keeps a watchful eye on the operation. Slowly and precisely, the giant structure is maneuvered towards the Vanguard's deck. Meter by meter, inch by inch. Everything goes as planned. It's a major success. And finally, the lower hull is perfectly floated onto the Vanguard. Shortly after the Vanguard's departure from Singapore, the project's next phase commences: the lifting and transport of the oil rig's topside components. All heavyweight champions in their class that require complex engineering to ensure a smooth and safe delivery. Carefully, the large structures are lifted onto the vessel. It's a team effort and shows once more Blue Water Shipping's veteran experience in applying tailor-made logistics to the oil and gas industry. Precisely, in record time, with 0 incidents, and to the customer's fullest satisfaction. Finally, Hercules places the derrick tower accurately on its pre-calculated position. The ship has to travel 8,800 miles through the Indian Ocean, rounding the Cape of Good Hope, and then crossing the vast Atlantic Ocean to finally reach Angra dos Reis, where just now, the Dockwise Vanguard is about to complete her journey. On her way, she had to deviate away from 2 tropical storms and battle unfavorable currents. But now, she's here. It's a magic light welcoming a mighty ship. The pilot gets on board to navigate the Vanguard to her float-off position. Only an hour later, the gigantic lower hull structure floats off the deck. Delivered on time and without a scratch, it's a major milestone in accomplishing the project. Shortly after the delivery of the lower hull, the pilot station at Angra dos Reis receives a call from Combi 3. Her captain reports she's on her final approach and ready to enter the bay. With 14 knots, she almost glides the remaining miles to the yard.
The motto is together we create solutions. It means that together with the clients and also the subcontractors, we sit down, we understand that our clients' difficulties, the challenges that they have to meet all their requirements to deliver the project or deliver the cargo in a safe way and deliver on time.
By creating solutions together, Blue Water Shipping has once more proven to be the right and trustful partner for even the most challenging logistic projects. No matter what size, no matter how complex, no matter where in the world, together we create solutions. Blue Water Shipping.
ABS is leading the way on the forefront of marine and offshore innovation for more than 150 years. We are tackling the most pressing technical, operational, and regulatory challenges in the industry, setting standards for safety and excellence as one of the world's leading maritime classification societies. Our mission is to promote the security of life and property and preserve the natural environment. At the heart of our mission is safety. What we do matters to the lives of people and the quality of the environment around the world. We're leading the way in the development of new safety standards, incorporating the latest technologies and risk-based approaches to periodic inspections. Our business is establishing and maintaining technical and safety standards throughout the life of marine vessels and offshore structures. ABS has a global team of surveyors, engineers, researchers, and regulatory specialists who provide a broad range of classification services, plus insight into new and emerging technical services designed to improve energy efficiency, environmental compliance, and life cycle management. ABS is a leader in innovation. We are a trusted partner with shipyards, owners, operators, designers, drilling contractors, and engineering companies. We collaborate globally with world-renowned universities. Our focus always lies towards the future, and we work tirelessly to create game-changing technology and to develop modern design standards. We are developing and using the most advanced technology to address the industry's top technical challenges, from cybersecurity, big data analytics, autonomous inspection technology, crew safety, and the application of analytical tools. From Houston to Shanghai, Athens to Rio, and London to Singapore, ABS is guiding advancements in the marine and offshore industries. We are passionate about making the world a safer place and promoting practical and innovative solutions. We continue to lead the way.
It's in our DNA. It's what drives us to accept the most challenging assignments in the world. To work in some of the most inhospitable places on the planet. It's what we do. And together, we deliver an integrated solutions approach to our clients. It's the projects we execute. It's who we are.
We are Fluor.
We are Fluor.
We are Fluor.
我们是 Fluor.
We are Fluor.
Somos Fluor.
McDermott is a company powered by people who share an enduring vision and uncompromising values. Working closely with our customers, we design smart solutions for offshore field development to help bring oil and gas to market safely, responsibly, and economically. Through advanced technology and the highest standards of performance, we deliver project certainty. McDermott is executing some of the most complex and challenging projects in the offshore energy business. Our global footprint of regional presence seeks to address national content while improving the communities in which we live and work. We are the partner of choice. Our expertise, vision, and values differentiate us and drive us to deliver excellence on every project, every time. McDermott, the right people, assets, and technology to bring project concepts to reality.
Technomac, an integrated engineering, fabrication and erection company, is geared to serve the growing needs of onshore and offshore oil and gas, marine, metals, power and infrastructure industries in the Middle East, Africa, Europe, the Far East and the Indian subcontinent. From a humble start in 2004 with 150 square feet office space and 6 employees on payroll, Technomac has grown to 1,500 plus employees. State-of-the-art manufacturing facility to meet industrial requirements like piping, pressure vessels, tankages, structural components, skids, modules, electrical and instrumentation, and equipment erection. As part of commitment towards continuous improvement, Technomac has implemented integrated quality and HSE management system in compliance with ISO 9001, ISO 14001 and OSAS 18001, in addition to API 2B, ASME, U, PP and R certifications and British Safety Council membership. To provide the utmost care and best services to customers, the operations are divided into 6 business units: onshore and offshore oil and gas projects, mechanical EPC projects, skids and pressure vessels, shutdown and maintenance, shipbuilding, ship repair and conversions, offshore and marine consultancy. Technomac has its strong presence in the UAE, Qatar, India and Saudi Arabia, with its headquarters strategically located in Hamria Free Zone, Sharjah. Technomac's quayside yard, with loadout facility, enables heavy fabrication and transportation of large onshore and offshore structures and modules to various parts of the globe. For the execution of time-bound projects, Technomac has well-equipped facilities with overhead cranes, its own fleet of mobile cranes, forklifts, CNC machines, fabrication machinery, blasting and painting booths with recovery system, workshops capable of handling carbon steel, stainless steel, and high-grade materials like duplex, super duplex, copper nickel and titanium. Technomac has proven its expertise in offshore oil and gas fabrication on various projects of Saudi Aramco, ADNOC, ONGC, Reliance, Qatar Gas, South Oil Iraq, Turkmen Gas, Maersk Oil Qatar, ENI, Dragon Oil and KJO, which resulted in partnering with many multinational contractors like J. Ray McDermott, Weatherford, Bumi Armada, Leighton Offshore, Petrofac, Swiber Offshore and Saipan. One of the first major projects executed by Technomac successfully was the architectural steel fabrication and erection works of Dubai International Airport Terminal 3, with a record of 0 accidents throughout the project span of 21 months. Technomac has executed projects in Emirates Aluminium, EMAL, Dubai Aluminium, Hindalco, Qatarlum, Rio Tinto, Alcan, Kitimat Smelter, Canada, Sphinx Titanium, Jazan, involving modular construction and loadout of green anode paste plant, anode rodding shop, gas treatment centres and fume treatment centres for technology partners like Alstom, ECL, Thieves Solios, Autotech and EPCMs like Bechtel and SNC Lavalin. These projects were delivered successfully with the highest level of customer satisfaction, which led to receipt of repeat orders. Technomac's contribution in the field of power, desalination and water treatment solutions are evident in the projects executed for Degremont Technologies, Entropy, Alstom, Mackie Boilers, Thermochemica, Bilfinger Babcock and Clyde Bergman. The projects include SWFGD, ESP, evaporators, stacks and diverters for heat recovery steam generator, deaerators, dampers and other associated systems for Marafik Yambu, NWC Saudi Arabia, CMI Energy Tunisia, Stalowa Wola Poland, Zwitina Project Libya and EGC Expansion Project Qatar. Technomac spread its wings to the Indian subcontinent, taking up the aluminium smelter projects of Hindalco, for which the company is involved in executing 21,000 metric tons of steel and equipment erection that includes gas treatment centers, fume treatment plant, storage tanks and piping. Technomac Marine and Offshore Consultancy, together with Offshore and Subsea Installation Division, gives complete solution to offshore field development and upgrades. Technomac takes care of end-to-end solution for feed studies and field development, load-out, float-off and transportation, pipe lay and flexible lay, installation engineering and project management, offshore T&I contract of topsides and jackets, subsea installations, brownfield and pipeline replacement, vessel upgrades, stability sea fastening, tow and mooring analysis, tender assistance and technical reviews. The division also specializes in impact and collision assessment, design of pressure vessels, project management, decommissioning studies. The project management and installation of cellar deck for Maersk Oil Qatar is a classic example of Technomac's expertise in offshore works. The scope of the work includes installation engineering, task risk assessment, load-out operation, trial lift and final offshore installation, which was completed with a high level of client satisfaction. Technomac's ship repair, shipbuilding and conversion division, with fully equipped repair workshop and machine shop in Dubai Maritime City, Hamria Free Zone Sharjah and Port of Fujairah, is engaged in dry docking, underwater hull repair, afloat repair, main engines overhauling, auxiliary and deck machinery refurbishment, hydroblasting, painting and electrical repairs of ships and rigs. The classic example of Technomac's expertise in handling unique projects is the conversion of a 100-meter flat-top barge into a floating knowledge enrichment center developed from the concept to its completion and handing over to Doha Land Qatar Foundation, which involves design, fabrication, erection and interior works done in a record-breaking time of 85 days. Other significant projects include rebuilding of shear leg pipe lay barge Hyundai 423 with all new firing line and tensioners, new building of anchor handling tugs and diving support vessels. The company's endeavour to achieve excellence in project execution and operational efficiency has earned international recognition and acclaim in the form of various awards like Hamria Top 3 Award for Engineering Excellence in 2011 and 2012, Best Performance Safety Awards and various other appreciation from multinational customers. Technomac upholds the philosophy of delivering high-quality projects safely, on time and within budget to the utmost satisfaction of customers. This determination propels the company towards operational excellence through continuous improvement.
The Aries Group of companies was launched in 1998 with a vision of providing quality services to the maritime industry. The group, launched by Sohan Roy, a renowned naval architect with 2.5 decades of global experience, a multifaceted personality, now houses one of the largest engineering and inspection and oil and gas firms in the world. Our core activities are related to oil and gas, offshore, petrochemical, and marine sectors. Built with the building blocks of innovative technology, customer trust, and astute leadership, the company scaled the heights of growth to become a consortium of 43 companies, spread over 15 countries in just 18 years. The company, over the last 3 years, has successfully forayed into new territories like entertainment, cinema, 3D technology, healthcare, and technical education, while consolidating our leadership in the maritime industry. The Aries team of over 1,400 engineers and professionals, having performed over 10,000 surveys, provides innovative technology solutions to cater to the wide-ranging needs of the maritime industry through its specialty divisions, including naval architecture and engineering solution. 1. Offshore engineering, inspection and maintenance, ultrasonic thickness gauging, non-destructive testing, OCTG, load test, lifting inspection, third-party inspection services, plant inspection, rope access, marine survey, project management, yacht interior, marine software and technical documentation, electrical and instrumentation, EIT, advanced 3D survey technique, corrosion control services, 3D rendering with interior designing services, hull integrity and life expectancy survey, risk-based inspection, signage survey, valve instrumentation, calibration and maintenance, preventive, predictive maintenance survey, mechanical testing and metallurgical services, TPI and QA/QC services, scaffolding services, equipments and trading, blasting and painting services, ECDIS commissioning, visual media, software solutions, research and training, and so on. Headquartered at Sharjah, Aries has branches in the UAE, Qatar, Bahrain, Oman, Saudi Arabia, Kuwait, Azerbaijan, China, India, Singapore, Malaysia, USA, UK, Italy, and Iran. Aries serves over 3,000 clients from several facets of the maritime, oil and gas, media, and infrastructure industries across the globe. Aries follows Integrated Management System IMS, certified by ISO 9001, 2008, 29001, 14001, and OSHA's 18001. Aries Group provides innovative designs for new build and conversions of marine and offshore structures. Our offshore engineering division caters specifically to the engineering needs of the oil and gas industry. We perform complex analysis works including structural integrity assessments, site-specific assessments, fatigue analysis, and global strength analysis of offshore rigs, platforms, semi-submersibles, etc. One of our flagship products include the Aerion series of lift boats and self-elevating platforms, completely designed and developed in-house. Aries Inspection and Maintenance Division has more than 500 experienced multidisciplinary professionals. This division has the world's largest ultrasonic thickness hull survey team, approved by all IACS members, providing various services to marine and offshore industries. Our team, consisting of IRATA qualified and experienced technicians, are highly skilled in rope access and certified for various trades. Aries Rope Access Training Center, located in India, is a dedicated training division of Aries Group with one of the finest rope access training facilities available in the industry. We are one of the leading non-destructive testing service providers, offering NDT, mechanical testing lab, OCTG inspection, lifting equipment inspection, QA/QC services, API inspection, on-site calibration, etc. We have registered with all major oil field companies such as Gasco, ADCO, Zadco, ADMA, Takrir, NDC, Advia, Maersk, QP, Qatar Gas, Uras Gas, and many more. Aries constantly strives to meet HAC requirements and equipment conditioning monitoring to lessen the likelihood of failure. Aries Project Management and Survey Division ensures comprehensive supervision of complex activities like structural fabrication, installation and commissioning of machinery, piping, and electrical systems on ships and offshore installations. Our survey team is armed with the most modern 3D scanning equipment in the market, capable of taking accurate measurements at long distances. Aries Electrical and Instrumentation Division boasts of a multidisciplinary team providing excellent industrial and marine services to our offshore and marine clients.
Check.
We are a leading provider of EX surveys for the oil and gas industry, and RTEC, our equipment supply and trading team, is capable of supplying equipment and instruments for the maritime industry. Aries Corrosion Control Services is equipped with a dedicated team of qualified professionals to do all kinds of coating rectification in yards, offshore and water. Aries Marking Services helps to raise the level of safety awareness by standardizing hazards identification and system layout. The entry into the Guinness Book of World Records of our Steel Snake boat with the largest canoe crew and the eco-friendly solar-powered steel houseboat, Boatel, demonstrates the competence of our research and development wing. Aries International Interiors provides shipping and civil industries a one-stop solution to their interior design. Our revolutionary venture, Marine Biztv, is the first 24-hour free-to-air global maritime TV channel and is telecast on a wide range of media, including web TV with video archiving, ITV and IPTV. Our commitment towards the maritime fraternity is evident through the introduction of high-profile events like International Maritime Video and Excellence Awards, ShipTech, NDT Level 4, Boat India, Mastec, Marine Offshore Survey, ME Forum, Offshore Symposium, Maritime Cultural Olympics, Maritime Quiz, Mariners Cricket, and many more. Our Creations Wing came out with the first ever Hollywood film created by mariners. The epic movie Dam 999 won 5 Oscar selections in 3 categories: Original Score, Original Songs, and Best Picture. The film won 2 Global Music Awards, GMA, and was well appreciated at various film festivals across the world. The Aries Group has launched Medi Biztv, the first 24-hour free-to-air global healthcare channel that focuses on health and well-being. Aries eSolutions has an unmatched hand in web and mobile development services expertise and technology with the best tools, software and processes in the business. Joining the series of creative initiatives of Aries Group is Aries International Maritime Research Institute, AMRI, an interactive iUniversity aimed at improving the quality of technical education and to promote innovation and research in marine engineering. AMRI offers the industry-relevant skill-based training and short-term certification program to young maritime professionals. Aries Group, under the brand name of Epica, Asia's pioneering 3D technology solution provider, created the world's first ever 3D TV that can be watched without wearing glasses. Epica series also features 3D smartphones, 3D tabs, 3D laptops, 3D PCs, and 3D picture frames. Epica enjoys global reputation in conversion of 2D to 3D visualization with comprehensive solutions from pre to post-production. Aries Plex creates an amazing world of movies encompassing a chain of commercial theaters with state-of-the-art features. With the latest addition to the family, Aries Vismayas Max, India's only double 4K Dolby Atmos mixing studio, Aries Group can proudly claim to be one of the best film and studio networks in India. The ongoing Project Indiewood is designed as a blueprint for bringing about qualitative changes in the Indian film industry by introducing technology-based infrastructure and new business models. This $10 billion project is expected to be completed in 5 years. As part of the CSR activities, Aries Group initiated the world's first charity movie, Jalam, which paved the way for an entirely new concept in film production. Through the demonstration of our motto, work is worship, time is God, and clocks are idols, Aries Group endeavors to deliver quality services promptly and cost-effectively to all clientele. The group's management policies on job security, retirement plans, and parental welfare ensures higher staff commitment and ultimately complete customer satisfaction. The trust of over 3,000 clients all over the world inspires us to push the envelope in whatever we do. Under the astute leadership of Sohan Roy, our CEO, the company has a well-defined set of goals and vision.
Yes. I'm here. No input connected.
മിനിറ്റ് ശരിയാവുന്നുണ്ടോ?
മറ്റേ വിളിക്കണം.
പുള്ളീനെ ഒന്ന് വിളിക്കാം. കാരണം ഇതിന്റെ ഈ കണക്ഷൻ പുള്ളീനെ ഒന്ന് ഞാൻ ഒന്ന് റീസ്റ്റാർട്ട് ചെയ്ത് നോക്കിയാലോ. ഇത് വേണ്ടി വരില്ല. പുള്ളിക്ക് എനിക്ക്
a day, 365 days a year. Across the world's seas, Class NK is committed to safety at sea and protecting the marine environment. From the classification of ships and offshore structures, to software and consulting services responding to the industry's demands, and the latest R&D for the next generation. We contribute to society by ensuring the safety of life and property at sea and protecting the marine environment. The first classification society in Asia, Class NK, was established in 1899 in Japan. We have accumulated over a century of technical experience in ships and offshore structures through our surveys, audits, and research. Class NK is one of the world's leading classification societies, with 20% of the world's merchant fleet under class. A testament to our ability in delivering top-quality, tailored services to our clients.
Welcome back. We are about to start the next session. Can I have everyone in the hall, please? And please be comfortable and take your seat, please. Thank you very much. So we are starting our afternoon session now, and I'll hand over the podium to Mr. Nishat.
Hi, good afternoon, everyone. Welcome back. Hope all of you are settled. Our next presentation is by Mr. Mohammad Shifas on future shipyards. A small introduction on Mr. Mohammad Shifas. He's a naval architect with over 16 years of experience in shipbuilding, ship design, offshore design, installation engineering, and subsea engineering. He started his career as a production engineer for defense ships in Goa shipyard and later moved to UAE and worked with organizations like Granville, Dry Docks. Throughout his tenure, he has been associated with various design assessments, including FPSOs, semi-subs, yachts, and jackups. So he has got immense experience in the design field as well as offshore field. So I would like to welcome Mr. Shifas to present his views on future shipyards.
Thank you, Nishad, for that introduction.
Good afternoon, ladies and gentlemen. Our topic for discussion today is Shipyard of the Future. Please note that this is based on my own ideas and past experience in working with shipyards. An overview of the subject today. We shall be looking at business drivers that bring in the business to shipyards, how these business drivers are affecting the shipyard capacity, or how these business drivers have affected shipyard capacity in the past and the current situation, relevance of technology in today's age, technology adoption, how the technology is changing ships into autonomous ships, recent developments in ship design that could affect the ship design in the future, possible technologies that can be applied into the shipyards based on emerging technologies, then how do we manage the transformation of shipyards from its current state to a technologically advanced one. Then we will see the conclusion. Business drivers. Shipyards sell services and not products. Basically, shipyards are selling their ability to build, repair, or convert ships. They are not like factories producing products. Major business drivers in a shipyard are trade through sea, oil and gas when it's from sea, wind energy from sea, wave energy. For countries with large coastlines, they need to protect their seas, so we have navies and coast guards coming up with defense ships. For leisure industry, yachts, cruise liners, etc. And in port operations, we have tugs and pilot boats bringing the business to shipyards. Now let us look at two macroeconomic indices that affect the shipyard business, the major ones. One is Baltic Dry Index. This gives a good judgment of demand for ships in sea trade. Let us look at a 30-year data of Baltic Dry Index. If we say that our reference value for analysis is say 2000, we can see that Baltic Dry Index was quite high between 2003 and 2011. Reasons for this were growth in Chinese economy, as well as the trade agreements in the past decade. Now let us look at another index, that is oil price. Again, if our reference figure is somewhere $40 to $50, oil price was quite high between 2005 and 2014. The specialty of last oil boom was oil companies were moving more and more into deeper water. That brought in a lot of business to shipyards. So shipyards were busy in building semi-subs, FPSOs, drill ships, and many support vessels. So there was an increased coupling between the shipyard business and oil price. So in short, a combination of shipyard or a combination of trade demand and offshore oil and gas activities almost happening simultaneously caused a huge expansion in shipyard capacity in the last 10 to 12 years. Now let us look at current situation. As we all know very well, global trade is down for many years, and oil price has crashed since last 2.5 years. So we are seeing a contraction in demand for shipyard services. These days, when two marine professionals meet, obvious question is, when would we be back to normal? Yes, if you are saying our normal is last 10 to 12 years, we are down from normal. But if you see a 30-year picture, probably we are back to normal. So what is the way ahead for shipyards? How do we see our future? Oil price is quite unpredictable. Also, the global trade is uncertain, especially when policies are drawn against globalization. They say best way to predict future is to create it. How do we create the future? One way could be to use technology. These days, when you hear the word technology, there are many keywords associated with it. Data, disruption, Internet of Things, drones, additive manufacturing or 3D printing. We are talking about ships, so autonomous ships, and technology adoption. Let us look at technology adoption. Back in early 2000, when internet boom happened, information technology companies thought all the human activities would be converted to online platform. They thought purchases would be online, shopping would be online, all the commercial activity would be through internet. So that they started building a lot of websites to cater to this demand. However, things did not happen the way they expected. So there was a crash in information technology sector that is known as .com bubble. So the time and user experience, but now look at the current situation. We all have advanced mobile phones, and through apps, not websites, we use apps to purchase many things online and do many of the commercial activities through online. So basically time as well as the user experience has got relevance in technology adoption. I am pretty sure that all of you have carried a small rectangular piece of paper today known as business card. Actually, do we need business card today? Really speaking, not. In the age of smartphones, we don't need business card. But still we have it, which means business card is not yet replaced by technology. So whenever we are talking about applying technology in any field, technology adoption is quite critical. One of the methods to assess that is technology hype cycle. A firm called Gartner every year publishes their technology hype cycle to assess the technology adoption rate. Look at the technology of autonomous ships. As we all know, we have some representative from Rolls-Royce here. They have an ambitious project to come up with the fully autonomous ships by 2035. And they plan to have a kind of partially autonomous remote control vessels by 2020. It's an ambitious project, and we do not know how far they will be able to achieve it. But that can bring in a lot of disruption in the business roles, which is existing right now. Actually, do we need a ship owner? If you heard Marco very clearly, the last sentence, he was talking about the roles of many people over here in the next 10 years. So when we have autonomous ships, do we need ship owners? Or a combination of shipyard? Shipyard can build, maintain, and probably monitor the ships as well. And ports have got their own control center. So if the ships are operating from port A to port B, probably port and shipyard combination can do the business, do the operation of the ship. So the technology can change the business role in the future. As we all know, Uber, they are the largest taxi operator in the world without owning a single taxi. Another initiative in this line is between Hyundai and Accenture. They were trying to develop something called Smart Ship, where the Hyundai, as a shipyard, was trying to monitor the ships, building the ship as well as monitoring the ship. So this is a kind of business model which is not existing for shipyard, which they can look into. Developments in ship design. Traditionally, ships are designed based on class rule, which is based on empirical formulas developed based on the past data. But with the development of special type of ships, especially in the offshore oil and gas sector, this had to change as there was not enough past data of the past operation. So design had to move from something based on rule-based to something based on the physics of the failure mode. So this kind of change is happening in many other areas of the design as well. For example, in second generation intact stability criteria, which has been under development for quite some time now, the failure mode instability is the criteria for stability, unlike the empirical GZ curve, which existed for so long. Another interesting development is deterministic vessel motion prediction using wave and current monitoring system. Here, a radar fitted on a vessel can capture the waves coming onto the vessel. As we know, radars can capture the objects coming to the vessel, so they can capture the wave data as well. This wave data, known as sea clutter, if that is fed into a hydrodynamic solver, it can predict the vessel motion at least 2 minutes in advance. If we can give the response to this motion, then probably the operation of the ship can become autonomous. This is quite advantageous in case of operations like LNG transfer, crane operations, etc. Please note that here, this is not like a heave compensation where you measure the heave and then apply the response. Here we are applying response in anticipation of expected motion. As said before, structural strength calculation is moving from rule-based to direct strength-based, and computational fluid dynamics continues to improve, where recently there was a conference organized by Lloyd's Register where they had designers from across the world discussing one particular case of tank testing with computational fluid dynamics. And their intention is to replace traditional tank testing method completely with CFD. Shipyard technologies. Please note that here I'm not talking about something fully developed technology, but concept ideas from outside the shipbuilding industry and trying to implement how that could affect or improve the shipyard efficiency and costs. One such technology is 3D printing. Shipbuilding is nothing but assembling of parts to whole. 3D printing or additive manufacturing has got many advantages. You don't have to keep items in the store. You can print equipment or whatever whenever you want. Also, you don't have to transfer it from the base of manufacture to shipyard. You can do that in the shipyard as well. Another interesting thing you can do here is a combination of 3D scanning and 3D printing. Many times, very old ships come for repair. They have a broken part of an equipment, and equipment manufacturer is no more existing. So probably we can 3D scan the part which is missing, probably repair the damaged piece of that part, and then print it and reuse it, and use it as spare part. For 3D printing, assessing the strength is a challenge. I think universities are coming up with a solution for that. Again, we heard about changes in which I'll talk in a minute. Hamburg ship model basing in Germany is using, for making their prototype, they are using 3D printing. What they say is there is a cost reduction of 30% and their lead time is slashed by 70%. Question is, can we 3D print a propeller? We heard in the last presentation that propeller material has changed. I mean, there are advantages changing the material into some other type than the traditional manganese bronze. So can we 3D print a propeller? Look at the disruption that the technology can bring into business models, which is existing now. Interestingly, we have a 3D printed office in a place which is very near to us where we are today. So we are talking about technologies that is around us. This is not something very far away from us. Only thing that we need to find out and apply in our own business areas. Another thing, production from 3D. Thinking in 2D is difficult. We have to look at a 2D drawing and imagine the 3D object. So these days, naval architect who is highly skilled uses 3D models to develop a concept shape or dimensions of the vessel. From that 3D model, he gives it to a production engineer who gives a structure, plates, stiffeners, etc. Their intention is to produce something like this, which is a 3D hull block. But the way they go from this 3D model is quite interesting. They go from a 3D production model to a 2D drawing. And that has to be read by somebody in the shop floor who is low skilled. I think this is a kind of bottleneck. We are giving a complex thing to somebody in the shop floor who is low skilled. So what could be the possible solution? One possible solution could be to use 3D visualization. These days, we have many 3D visualization tools available, which is portable, like tabs or even large screens, or sometimes we don't even need screens. So can we use or can we take advantage of this? Technology adoption is quite a challenge here, especially because drawings are easy to handle. But still, if you can improve the user experience, probably that will get adopted. And the benefit here could be reduction in the production detailing as well as the skill level required in the shop floor. Also, errors could be reduced. Shipyard technology, another technology that is possible. Look at the way how we paint the ships right now. We have hanging scaffolding. It's an afloat ship, so we have a pontoon. Then there is a man lift, and then man is standing over here, and they're trying to paint. Here, a kind of unsafe activity is happening to paint the hull. What is the solution? Can we use drones for painting the ship's hull? Drone art is quite useful to use artistic painting, and if you search in Google, there are many developments happening to use drones for painting the buildings. So can we think of using drones for painting the ship hull? Imagine the benefits. You can have 10 drones painting the ship hull. Probably would be happening much faster than the way you paint it now, without all kind of accessories like scaffolding and pontoons, man lift, etc. Another possibility to use internal painting, where we have large tanks. Some of the classification society has been trying to develop drones for inspection. Another possibility is to use for material handling within the yard, especially to transfer something from the berth to the height 30 to 40 meter high vessels. Again, drone taxi services are coming to Dubai in July. So technology is not alien, it's around us. Another possible application could be use of a kind of Internet of Things in dock blocks. At the moment, once the docking plan is issued from the engineering office, we don't have a control of actual position of the dock blocks. So even with the available technologies, we should be able to get accurate position of the dock blocks. So advantage here should be, if you have to make a next docking flap for the next docking, we have the data of the real-time position of the dock blocks. Also, when the dock is in the flooded condition, we know exactly the position of the dock blocks, so we don't have to send somebody down in the water to check the actual position of the dock block. We are talking about autonomous ships, which is happening in the faraway seas, far away from human eyes. So if we are talking about autonomous ships, why can't we think about remote-controlled docking operation, which is happening in front of our eyes and in a sheltered water environment? This could be far away, but again, something to think about. How do we transform a shipyard from its current state to technologically advanced one? As we have seen now, we have to have technologies from outside the shipyard, because technologies outside the shipyard are developing much faster than what shipyards could think of. So we have to have knowledge of technologies that is happening outside. Then we need to identify the suitable operation within the shipyard where these technologies can be applied. We have seen few of them now. Then, as I mentioned before, technology adoption is a very key area. So we have to assess the user experience so that it can get accepted. Then, shipyard business is not like a car factory, or it's not like aeroplane manufacturing unit where the things are standardized across the world. Here, the culture is different as well as facilities are different. So we may have to do some kind of a customization. So all these are done, then we can think of implementation. In conclusion, technology revolution is to redefine shipping or shipyard business. This is definitely going to happen. Rolls-Royce is thinking of about a year like 2035 for their autonomous ships. But if we put the right focus, some of the technologies which I have mentioned now could be developed much earlier than that. And that could be used for benefit of the cost as well as the efficiencies of the shipyard that could give a lot of competitive edge in comparison to low-cost destination of shipbuilding. That will reduce the human interaction and also errors. This will provide a safer working environment. With regard to challenges, yes, we may have to develop these technologies for the applications within the shipyard. We may have to do kind of testing and opportunities. We are in a place like where we are today, where every day smart initiatives come out. So we are in a place where these smart initiatives come out every day. So why can't we benefit from such kind of initiatives and try to apply that technologies within our field of work and benefit our cost and improve our business than waiting for something like oil price to come up. Thank you, MAST, for giving me this opportunity, and I thank all of you for listening to me.
Thank you, Shifas, for the informative session. Question and answers? General questions?
Thank you, Shifas. Whenever a new technology comes into the industry or an enhancement is recommended, normally what we have seen is that there is a natural reluctance towards accepting the technology, maybe because of the fact that there is a capital investment required for this. So you have mentioned that maybe shipyards can take the role of operators, but the major thing that the capital investment, can they bear the cost, or they will have to, pass it over to someone else? What is your take on that? Because that's the major challenge over here.
Yeah, then naturally shipyards have to take the capital because they're getting the benefit from the transporting the cargo. Okay, so basically they will have to transfer that cost into the customers. Yes, exactly. Basically, I mean, it's only kind of idea or thought process, because business roles are, as we discuss all the day today, is going to change. Okay. Which we have, as we seen even the last presentation, if you have listened it properly, I'm sure that you have done. So it is going to change. So what could take what shape it could take, it's only future can tell us. Okay, unless there is a reward for accepting this technology, nobody there is a reluctance. There is a reluctance. There should be some reward for the shipyard to accept these technologies. So generally, is there something which is happening to promote this? I'm aware of a few cases, and I think Canadian shipbuilding, they are doing some kind of research in virtual reality and things like that to improve the shipyard technology. Okay. I think nobody has actually thought of how we can improve, because so many things are happening outside, but we don't see that kind of change happening within the shipyards. Okay, something like the waiver for some of the service charges or something like that, unless you issue it to the shipyard, they may not be in a No, I think it's all about how do you benefit from the cost. If you go for a kind of painting with using the drones, you don't have a lot of accessories. Okay. You don't need a lot of accessories. You are cutting a lot of costs. Of course, I don't think developing a technology using drone is so costly, because they are developing technology for many other things. So it could be a parallel development. Okay. Yeah. In the safety aspect also, I think it is better. It is better, yeah. Okay. Thank you.
Anyone else?
Somebody here.
Yeah, this is Mikael Hansen. I have a question. One of your earlier slides was mentioning a driver that shipyards may one day become ship owners. Yeah. And no, I'm not talking about fully concrete things. I'm just throwing up the ideas. That's all. Yeah. I don't want to have anything against the ship owners. Nothing against it. No. But if you listen, what in the last presentation, it was quite clear. The roles are going to change. It will. I mean, right now, what I see shipyards when they take orders from ship owners at as little as 2% down, and in a difficult offshore environment that we have now, when ship owners can say, I can walk away from my purchase, and in effect, what's happening is the shipyards are de facto becoming ship owners temporarily, but they don't want to be ship owners. So I don't see at this time that is a strong push from the shipyards to become ship owners.
No. I would say that the way ahead for shipyards would be to build smarter ships. I mean, that is the way it is going to happen. So that is a benefit for the ship operator or whoever, or come up with smarter ship which is better cost effective than what is today.
Oh, fair enough. Thank you.
Yeah, Shifas, it's quite a very interesting presentation actually. You covered so many things. I was thinking on the segment of robots actually. So is there any specific reason that you did not cover robots that can also do a lot of things on the shipyard development to do everything faster?
Exactly, but the reason is I've been hearing about robotic ship welding for quite some time. Maybe at that time I entered into this industry, but nothing much has changed over the years. Especially robotic welding. That I did not use. That is another area of development which is happening, robotic welding. But these things are coming from outside, which was not existing, and this has got possibility to change many things.
But still, there are a lot of developments happening in the robotic segment, especially the welding, the cutting, the prefabrication, assembly segment.
So that is something already existing. So there is nothing more innovative to be in that, I think.
Okay, right. Thank you.
One more question, if any. That's it. Okay, I invite Dr. Leske to present one memento for Shifas. Thank you, Dr. Leske. Thank you, Shifas.
We're straight going into the next session. Let me call upon Mr. Justin to do the honors.
Good afternoon, everyone. See, afternoon sessions in any seminar is very challenging, especially after a delicious lunch like this. But anyway, the paper from Mr. Shifas was so refreshing and it has waken us up. So now it is easy. Okay, now we are entering into the second panel discussion of the day. A very relevant topic in the current scenario: sustainable energy, impact of regulations. As we are all aware, nowadays a lot of emphasis is given to environmental protection by IMO. As part of this, a number of new regulations have come into force in these days, which will be talked about in this session. I'm sure, taking into consideration of the current scenario of the shipping industry, there will be a lot of questions which will be raised in this session, and I'm sure we have got 3 experts in the field who can answer those. The session will be moderated by Mr. Simon Shaw. Mr. Simon Shaw is a senior engineering specialist with ABS and was relocated to Dubai in June 2015. He currently heads the machinery team in the ABS Dubai Engineering Office. During the 8 years in ABS Singapore, he was the lead machinery engineer for numerous OSVs and offshore conversion projects for FPSOs and FSOs classed in the Pacific Division. He was also involved in the classing of turret and fuel mooring systems. He is also the subject matter expert for the Pacific Division in classing of underwater systems. He has been speaking regularly on the various environmental updates at recent conferences and seminars. So, please join me to welcome Mr. Simon Shaw to the stage. The next in the panel of experts is Mr. Matthew Plumtree. He is the manager of Green Technology Solutions Department at Galton's Company Limited, Dubai branch. A qualified naval architect, he has over 20 years of engineering and management experience in the marine, oil and gas, and energy sectors, and recently completed an executive MBA at Hult International Business School. He worked in various ship repair yards in UK. After that, he joined Lloyd's Register for a short time. Then he moved to Dubai. He was my colleague in Dubai Dry Docks before. So after Dubai Dry Docks, he is in the current position as manager of Green Technology Solutions Department in Galton's. Please join me to welcome Matthew Plumtree to the stage. The third person in the panel is Naveen Nair. Mr. Naveen Nair is a naval architect by profession with a post-graduation in warship design from IIT Delhi. He has more than 16 years experience in the marine sector. He served for 10 years in the Indian Navy, where he held various positions including production manager of a defense shipyard and a core member of basic design team of a stealth destroyer. After completing his naval tenure, he joined the design team of L&T Shipbuilding in India. Currently, he holds the position of technical manager of Ares Marine Engineering, leading a team of more than 100 engineers and draftsmen involved in the new build, retrofits, conversions and modifications of different types of marine projects worldwide. Being involved in the feasibility studies, especially on installation of ballast water treatment systems, he has knowledge of maritime regulatory requirements related to these ballast water management systems. His team had been involved in the design and engineering for installation of ballast water treatment systems in over 40 vessels. So, please join me to welcome Mr. Naveen Nair to the stage. Now I request moderator Mr. Simon to take over the session.
Thank you, Justin, and very good afternoon, ladies and gentlemen. Thank you for attending today. I would like to also thank Mastec for inviting ABS and me, giving us the opportunity to provide an environmental regulatory update. So today's panel session, as we can see, we have two subject experts as well on ballast water treatment. But before we get into the panel discussion, let's just run through some of the latest environmental updates. So in the next 20 minutes or so, we're going to run through the Ballast Water Treatment Convention, ship recycling, and as well as some new air emissions environmental updates, mainly pertaining to SOx and NOx, as well as CO2 EU MRV monitoring. Now let's kickstart the session for today with ballast water management implementation. Now last year, in the last quarter in October, MEPC 70 was convened, and during which it was decided that ballast water management treatment systems are going to be mandatory in the very near future. However, what was not decided was the actual implementation date. So now, as we can see on the slides, there are actually two different scenarios that could happen, and this will eventually be decided in the upcoming MEPC 71 session. Now, it was scheduled to take place in May this year. However, we have seen that there's an update to it, and it has been postponed to July 2017. So what this essentially means is, if it was not decided that implementation date is to be postponed, according to the initial IMO rectification dates, we are looking at implementation as soon as 8 September this year. So there are two scenarios presented. One is in this current session of MEPC 71, slated to take place in July this year. Nothing changes. So implementation, ascension of the Ballast Water Management Convention has already taken place. 1 year after that, that is 8 September of this year, the convention goes into force. All ships must fit a ballast water treatment system. The second scenario is it could possibly be postponed for another 2 years to give industry more time to catch up, for the vendors and the shipyards owners to have some time to prepare their vessels to enable it to comply with the latest regulations. Now, when we say latest regulations, the guidelines have already been published for quite some time. However, during the latest MEPC session last year, they have also adopted and accepted updated what we consider a G8 guidelines for ballast water management and treatment systems testing. So ascension of the convention had taken place after Finland did it on 8 September 2016. 35% of the world's gross tonnage was exceeded at that time. Currently, we have 53.41%, comprising of 54 flag states. So if nothing changes during the latest meeting to take place in July of this year, the convention will go into force 8 September 2017. So this essentially means that all vessels involved in international trade are required to comply to this convention, and you will need to fit a ballast water treatment system on board. It's currently still unsettled, and we will provide an update as and when IMO meeting has taken place. We spoke also about the revised G8 guidelines. So this has now been formulated into MEPC 279, so in which it details the different criteria on how they assess the effectiveness of a ballast water management or treatment system. So several key components have been changed from the initial guideline and testing. So it is recommended that all systems that are fitted be compliant to the latest G8 guidelines, otherwise also now known as MEPC 279. And this guideline should actually be applied as soon as possible, but no later than October of next year. So IMO recommends that ballast water treatment systems that are installed on board ships on or after 28 October 2020 should be approved, taking into account the latest guidelines. That means if you have an existing system on board, you should bear this in mind. And prior to 28 October 2020, they should be approved, taking into account the initial G8 guidelines, MEPC 174, or, again, preferably, the latest guideline. So one key thing that we need to know is if your vessels are trading with the US, or there's an intention that you will actually have your vessels sail into US waters, it is critical to note that US is not part of the flag states that have ratified the IMO Ballast Water Convention. However, they have issued their own version of the convention, which is in many ways similar or even more stringent than the IMO Convention. So to date, they have issued their third update to their bulletin addressing Ballast Water Convention, as well as the implementation schedules. So the last update was received on 6th of March 2017. It talks about extension of compliance date. Now, what kind of compliance we're essentially looking for are ships that actually sail into the US waters and have a system fitted on board. Now, the system that's fitted on board any vessel going to the US should be US CG type approved. Okay, that means it's complying to the USCG guidelines. Now, one of the major differences between the USCG guidelines and the IMO guidelines is the way they determine the effectiveness of the system. Now, IMO allows you to do some lab tests, and from the results, consider a certain percentage of the organisms disabled. Now, the definition of disabled in the US means killed. Means the system should actually eliminate all the living organisms in it. So that's a key difference between how the IMO actually assesses a system by percentage allowable remaining, whereas US requires the organisms to actually be killed. So this has resulted in a discrepancy in the number of systems that actually are IMO approved and USCG compliant. However, to date, there are already systems that are USCG compliant. So there are few of them. I understand that there are 3 already approved and 2 more in their final stages. There will be more eventually coming to the market. But for the time being, since there's already a USCG approved system, USCG has also correspondingly issued latest updates to how they consider acceptance of alternate compliance systems. We'll see that in a minute in the next slide. And more importantly to note is how they consider a request for an extension of deadlines when it comes to a vessel that doesn't have any ballast water management system installed on board. So the issuance of the supplementary extensions should not be anticipated for vessels with compliance dates of January 1st, 2021 or later. So this date is fluid, it's been changing, it has been revised a few times, and I'm just drawing attention to that particular aspect. So as mentioned earlier, they have not rectified any of the IMO conventions, but any ships that's anticipated to discharge ballast water in the US must be in compliance with the USCG ballast water regulations, as well as the US EPA VGP, that's the vessel's general permit, as well as individual state requirements. Now, as we can see, 16 of the individual US states have their own ballast water requirements, of which the most stringent has been issued by California. So these US regulations apply to if any ballast water is discharged within the US waters. And before you can discharge any ballast water, it firstly needs to be discharged via a USCG type approved system. Now, alternate management systems, as so addressed by the US Coast Guard, actually refers to IMO approved systems. So for vessels operating under the Extension Compliance Date Program, as we saw earlier, if this system was installed during the extension, then the alternate system may be only used for 5 years after the vessel's extended compliance date, which translated to layman's English, it means eventually you are still going to need to install a US type approved system, or hope that the system that you have installed eventually obtains US type approval. So unfortunately, this has created a scenario where people are now unsure of whether they want to install or not install the systems, because you're potentially faced with the conflict of installing a system that ultimately does not meet the US requirements, and you may have to install a separate system or obtain an upgrade for it. We're going to talk a bit more on some challenges that this Ballast Water Convention has raised, and that's why we have our 2 other guests sitting here on the panel. We're going to hand over the time shortly to them. And for now, we'll just cut off a bit out, and we'll go to look at some of the other regulations that have also came into force recently, of which we're looking firstly at ship recycling regulations. So it was effective in force 24 months after rectification criteria is met. We're talking about IMO Hong Kong Convention. So currently it stands that there are 15 states comprising 40% of the world's gross tonnage, with a combined maximum annual ship recycling volume during 10 years, not less than 3% of the combined tonnage of rectifying states. As of today, only 5 countries, Belgium, Congo, France, Norway, and Panama, comprising 19.99. So that's 20% of the gross tonnage. So this convention is near to ascension, has not been rectified. So the next also is EU regulation. It was effective in force on 30th December 2013. The date of application is either the earlier of 6 months after combined maximum annual ship recycling output of recycling facilities in the EU, which is not less than 2.5 mLDT on 31st December 2018. And it applies to all EU flagships and non-EU flagships that are calling in US ports. Essentially, any ship that goes into the US waters or calls into their ports. A summary of the implementation schedule. So, Hong Kong Convention applies after it goes effective in force for new ships at delivery, and for existing ships not later than 5 years after the convention is accepted. And for EU Convention, it's likewise, and for existing ships by 31st December 2020. Ship recycling comes and only affects ships greater than 500 gross tons, and it requires that all ships' recycling facilities be authorized by competent authorities. We'll move next to NOx, so nitrogen oxides. Currently, the NOx environmental consideration areas, North American area and Caribbean Sea area. The ICA areas have actually been slightly modified recently, but in general, it still sticks to those areas. And MEPC 70 has approved to designate the North Sea and Baltic Sea as additional emission control areas as well. So amendments to Regulation 13 of MARPO Annex 6 when drafted with a view towards adoption at MEPC 71. Means a paper has been tabled and it will be considered at MEPC 71 taking place in July of this year. So these regulations applies to all ships constructed on or after 1st January 2021 and operating in the Baltic and North Sea environmental control areas. So for SOx, there were 2 new papers that were tabled during the last IMO meeting, MEPC 70, which assesses the fuel oil availability. So essentially, the executive summary was presented to the Secretariat, and it concludes that the refinery sector had the capability to supply sufficient quantities to meet the demand from both marine and non-marine related fuels. So in regards to review of fuel oil capability, it concludes that it will, however, lack sufficient capacity in 2020 to fully respond to the global sulfur cap. So therefore, the committee had agreed to retain the current text of the MARPO Annex 6, Regulation 14, and accordingly, the sulfur content of the fuel oil used by ships globally is not to exceed 0.5% as of 1st January 2020. And this is addressed in MEPC 280. Another topic that's coming into force, which affects mainly the larger vessels greater than 5,000 gross tons, is CO2 monitoring, otherwise known as EU MRV. So ABS is the first class society in the world to be accredited to verify for compliance. And we have a dedicated center located in Greece specializing in EU MRV compliance. So if anybody has any questions thereafter on EU MRV, you may send us an email and we will link you up with the appropriate personnel. It's applicable in general to all ships of 5,000 gross tons and above on voyages to and from or between the EU ports. So EC had published proposal for CO2 emissions in MRV regulation on 28 June 2013. So it was approved by the Parliament on 29th April 2015, and as of now, it has already entered into force 1st July 2015. So the implementation phase, we may circulate these cut sheets at a later date, but pointer is not working. It's okay. We can see the timeline over there. Basically, by 30th June 2019, it will be fully enforced. Okay, and this entails the couple of the followings. So draft amendments to MARPO Annex 6 was adopted at MEPC 70. There's a new regulation 22A which involves the collection and reporting of ship fuel oil consumption data. So this has been summarized in MEPC 278, which details data collection systems for fuel oil consumption on board of ships. So within 3 months at the end of each calendar year, the ship shall report to its respective flag administrations or any of the designated recognized organizations on the aggregated data obtained from their vessel fleet. So responsibility rests with the flag administrations to verify the data. A statement of compliance shall also be issued to the ships no later than 5 months from the beginning of each calendar year. Flag administration shall transfer the annual values to the IMO Ship Fuel Consumption Committee database no later than 1 month after issuing the statement of compliance. So, as I mentioned earlier, for more details on this convention, please feel free to drop us an email. So, ABS also offers various different evaluation services for owners or shipbuilders to consult with us with regards to finding the appropriate mix or the perfect balance that you require for implementation of the regulations in compliance to these regulations for your specific vessel fleet. So we offer market evaluation services, energy efficient analysis, operational fuel performance proposals, concept evaluation on how you can improve or suggest ideas on which would be the best systems for it. We can give you guidance on environmental compliance, and our global marine team would deliver market evaluations, energy efficiencies, and regulatory compliance whilst optimizing vessel performance. So these services, as mentioned earlier, are available, and you're welcome to contact us. That concludes the presentation. We will now move into the session for ballast water treatment, a detailed discussion on it with our two panelists. May I first invite Matthew, perhaps, to come and share a few words on his background and experience before we move into the session proper. Matthew, please.
Okay, good afternoon, gentlemen, and thank you very much for having me here at Mastec. So very quickly, I'm just going to, and Simon's just really thrown me the proverbial hot ball. Some of the challenges that we face, or have faced at Galton's when it comes to retrofitting of ballast water systems. We've been involved now in the environmental regulation business since 2010. And I guess the biggest challenge that we are experiencing when it comes to retrofit installations is people's acceptance that it takes time to plan and to prepare for these. It's not a simple system that you're just trying to put into the engine room. It's some of these systems are quite large, they're quite complex, and they can take up a lot of space. So trying to squeeze this system into a space that was optimized when the vessel was first built can be quite challenging. Obviously the cost of the systems is also a significant factor and challenge that we face, both in terms of the cost of the actual system for the treatment, but also the retrofit process and the changes that need to be done. Lead times at the moment for most of the systems are in the region of around 4 to 6 months. But once regulation is really enforced, and that's only going to go upwards, I would think. And especially when we look at also the exhaust and the sulfur regulations or requirement coming on stream. A lot of the exhaust gas scrubbers also utilise similar filters to those utilised in the ballast water treatment system. So there is going to be a bottleneck when it comes to production filters in the future. Okay. The main challenges I think that we face from a retrofit point of view is the planning, the preparation, and the space constraints. Obviously, once we're trying to put the installations on board.
Thank you, Matthew. And may we now also invite Navin to just give a brief introduction and his background, having also, we heard earlier, retrofitted more than 40 vessels. Navin, please.
Yeah, good afternoon, ladies and gentlemen. Thank you for the kind introduction. Essentially, the challenges that we have faced are very similar to what Matthew described a minute back. The most difficult aspect is to get to overcome the psychological barrier with my client, because he is forced to install a system, of course, for the overall good of the environment. But when you look from the client's point of view, he is not getting any economic advantage by installing this system. And it's not a cheap system. As Matthew said, the price is in a few millions, in millions. If you look at the systems that are installed in most of the vessels, I'm talking about, say, vessels of about 150 meters and above, having ballast water capacities of maybe 500 meter cube and above, pump capacities of that range. So the owner has been procrastinating the decision to buy the system, and finally now, since he doesn't have a choice, he has decided to get it. It's late and he wants to install it quickly, and then as the consultant, that's the time when we enter. The second challenge that we face is, at least in some of the cases, the owner has already decided what is the type of ballast water treatment system that he wants to have on board. And sometimes the decision taken is not technically explainable, in the sense that we have come across owners having very big ballast pump capacities, having gone for a particular system, say a UV system, whereas a chemical treatment based system would have been more optimal. But either for lack of information or because of maybe he got a very good commercial deal from for a different type of treatment system, so he went for this. And then as an engineering firm, when we go in, we realize that the sizes of the equipments that have to go in are huge, and it's just nearly impossible to accommodate that within the space that's available there. Like Matthew said earlier, the challenge is so much more when you have to retrofit a system into an already working vessel, as against when you have to introduce the system at the new build stage. Because at the new build stage, it's as easy as installing another component of the vessel, because you have been planning for it, you know it's coming there, the spaces have been earmarked. But then in a retrofit, you have to find space for the components of these systems, and they are big, especially for large pump capacities. That's, of course, one challenge we face. The other challenge is that some of these systems don't have, they come with a lot of constraints, in the sense that you have to co-locate certain components. It's not a single component system. You have about 4 or 5 different components which are to be connected to each other, and certain distances have to be maintained between them, or certain distances cannot be exceeded. The equipment manufacturer imposes some constraints like that. Even when they don't impose a constraint, the owner doesn't want too much of extra piping or electrical cabling happening, so because it's all adding up on his cost. So this engineering involves a lot of effort in optimizing the possibilities that are there. So that's the main challenge that we face. And to top it all, it's the time, because just today we have a situation where we have a client calling us that, okay, I'm going to go from so-and-so point, I'm going to enter the dry dock. You come on board, do your engineering, and by the time I reach the dry dock, I want the drawings. So unfortunately, in a lot of instances, the level of complexity is not known to the ship owners. there is requirement of much more, what shall I say, enlightenment for them to understand that this requires planning and preparation, so that this is going to be a system that's going to be there on your vessel till she operates. So better give the required time and importance for it, considering the importance of this equipment. Yeah, so we're free to take questions. So these are the main challenges that we face.
So thank you very much, Naveen. Now we will take questions from the floor, and let's see how this goes. Is there anybody who has got some hot pressing question that they want to go first? Yes, the gentleman at the back, please. Can someone pass him a mic?
Thank you, panelists. Actually, being from a ship owner side, means who operates a small vessel fleet. Oh, sorry. Small vessel fleet. So I would like to, I'm not going around the rule as such. We have voluntarily complied for a vessel which was built a year back. We have a system fitted, but considering the space constraint again, if I understand correct, the ballast water treatment convention applies for IOPP renewal survey, means the certificate renewal for the ships, means after 8th of September this year. So if, and there is no, and I know it's open, and even ABS have come up with means allowing owners to delink from the survey window. So if I'm delinking my IOPP renewal from next year, so and get it done before 8th of September, so then I'm getting again a 5-year period. To just wanted to confirm and say, is that my right understanding, or is there anything against,
Okay, that's a good question. Now, that was something I didn't address earlier. Now, that's delinking of the IOPP certificate for implementation of the schedule. The regulation states that after the first IOPP survey, you are expected to comply. Now, many flag states have agreed, but not necessarily all of them. So, before you want to consider delinking of the IOPP survey, please speak to your class society, whichever, if it's ABS or otherwise. If it's ABS, please speak to us. And let us know which flag the vessel is currently under and what's your plan for it. Now, the IOPP survey delinking should be done this year. Now, it's already 2017, and 8 September 2017 is when the convention goes into force, unless there are some changes in the MEPC 71 meeting, which takes place in July of this year. So to answer that question specifically, first you need to consult with the class society whether the flag that the vessel is currently flying has already in principle or given some general guidance that they are open to the fact for delinking the IOPP survey. That's the first thing. Now the second thing would then be to schedule it before September this year. All right?
Thank you.
Sorry, Simon, just very quickly on that one. I mean, certainly we have experienced a lot of projects across the Galton stations. We have 7 stations where we have green technology centres of excellence. And we've experienced in many of these stations where projects have now been put on hold due to the vessel being decoupled from the IOPP. So it is happening, and it is a method for owners and operators to avoid the cost.
Certainly, I don't think it's a method for avoiding. It's something that eventually comes in, but if it doesn't fit in, for example, some of the owners may have fleets that are aging, and it's not, it doesn't make economic sense to fit $1 million system on a vessel that you're intending to remove from service. Once things are starting to look better, so this is possibly a way in the interim measure to prepare yourself better for it, I would say. But this has to be timed correctly.
Hi. My question is to Matthew. Matthew, how much is the average cost for an OSV to fit a new normal type ballast water management system?
What's the what sort of ballast capacity? I mean, you're probably looking at about €250,000 to €300,000 for the system itself. You're looking at around ballpark of $100,000 for the. Sorry, I'm mixing my currencies. You're looking probably around $300,000 for the system itself. About 100,000 probably for the engineering, and then you're looking at another couple of 100,000 for the installation and the pipework, etc.
So it would come average 500,000. Am I right?
500,000 to 600,000, yeah.
USD. Okay. Simon, the ballast water management convention doesn't exclude the barges which has got ballast water capacity. So how this is going to be addressed?
No, basically the convention applies to all of them that carry ballast water, or rather that discharge ballast water. So some owners have came up with ideas like they're going to go with freshwater ballast, provided that this is not a regular occurrence. Or we have also what we consider a same risk area concept. So that is between the flag states that agree within sufficiently close proximity, they regard that they are falling within the same risk area, and that transit or discharge of ballast water brought from the origin country would not adversely affect them in their waters. So this is what we consider a same risk area concept, which IMO has detailed sufficiently clear in the G7 guidelines. So if the flag states have a mutual agreement that they consider themselves under the same risk area, so this wouldn't apply to them, which means you get sort of a special consideration. So we expect that the same would be used for site-specific facilities like modules.
Yeah, today morning the presentation was about the float overs and all. So a barge, dump barge carrying a duck from here to, let's say, to India or any other parts to Far East, then it will be a challenge for these duck cargo barges to have this ballast water management system on board, and then because basically they do not have power at all and they may not be having deck space as well. So this will be a challenge, I believe.
I agree. So that probably would have to be specially considered. Would any of you have any input for that, for barges that go heavily ballasted or vice versa and come back very light? How do we deal with the exception? We couldn't potentially exchange ballast water on the way. Well, I guess for such systems, you would then need a treatment system to make sure you fully treat the water and then discharge it before discharging
But during the float over operation and all, I'm not sure, because they need a quick deballast operation.
Yeah, but if you're ballasting and deballasting within the same area, then this doesn't affect. It doesn't have any effect. The ballast water convention is intended for ballast water which you picked up in a different area and you're discharging it in a second area. So, which is why I said, like, for modules or site specific or moving within the same risk, what we consider the same risk area, then ballasting and deballasting, the convention doesn't have any impact on it.
Okay, thank you.
Hello, yes. Simon, I have one.
Yes. Yeah. Yes, sir. Yeah. Then. Yeah. No, but well, that is what we consider the D1 scheme. Right now, treatment is considered a D2 scheme. After the convention was rectified, D1 has become mandatory for now, and D2 is in implementation phase. So in future, treatment systems will be replacing the exchange method, and exchange method alone will not be sufficient. It may be used in tandem with the treatment systems, but alone will not be sufficient. So I can see where that was coming from, which was initial part that I got a bit confused, because the exchange method, which we are all pretty used to now, would warrant that halfway or during the middle of a voyage, you're supposed to have a complete deballast, and sometimes more than once. If you're using a flow-through method, at least 3 times the volume. So that would be a serious challenge if you are carrying accidentally heavy cargo, or you're going heavy and coming out light, or vice versa. So, yeah, but with the treatment systems, you are supposed to treat the water completely such that it would offer no harm or no additional risk to the area that you're discharging the ballast water in. Yes. And sorry, I missed, there was somebody else who was asking a question. Yes.
Just, I want to compliment what Saibal has asked. This, just to answer your question, this exchange system is applicable only till the September 17, 8th of September 2017, or the first renewal IOPP survey after 8th September 2017. After that, you have to fit the treatment system.
My question was in relation to the ballasting of the barges when they go from, let's say, from India to Singapore or something like that. So you don't expect those kind of barges to have a ballast water treatment plant in near future, because as you said, most of them are pretty old and nobody would like to spend $1 million on them. So for such barges, maybe the ballast water exchange will serve the purpose now. And well, if it gets completely out by 2017, it becomes a different game altogether. Thank you.
Yes, gentleman on the left.
I just have a question to the panel. I think after last year, when it became mandatory to be fitted September, everybody is counting on the can being kicked down the road. So what if this does not happen? How many vessels are converted? How much percentage of the fleet does now have a system which is approved by someone?
That is a very interesting question. And I was also wondering about the same. So maybe we can have a quick straw poll. Like, how many of the people in the room have vessels that you actually have started installing these ballast water treatment systems? Can we just have a show of hands if you had any vessels within your fleet that you had started installing this system? No? Nobody? So everybody is waiting for for it to be kicked down.
Sorry to come back again. Just on the equipment as such, so even the rules are, I'll say the ABS requirements also, they are changing. We have an equipment, and as per the previous requirement, means till 2016, the convention requires a bypass line from the original to bypass the equipment as such. So 2017, the first rule requirement came that that bypass, if you're opening the bypass line, the system have to recognize and record that bypass also. But the equipment we have don't have that, because we did a voluntarily compliance a year back. So now what happens to us?
So I think this falls under the category of the existing systems. Okay, that you will be specially considered on a case-by-case basis. Eventually, sometime down the road, you may be made to upgrade or modify the system to comply fully. But it may come under the alternate management systems, or some special consideration may be made in the case for vessels that have done it on a voluntary basis, which is similar to what the US Coast Guard has stipulated. Like, if you don't have a US approved system currently, but you are visiting or calling on a US port, and pending the outcome of the extension dates, you may get like up to 5 years or 2021, by which time you would need to install a US approved system, unless the system that you have installed has also managed to get US approved, US type approval. And if the system, sometimes the same system has been upgraded in order to comply with the US regulations. And if yours was not the upgraded version of the system, you would then be required to upgrade to a version that has obtained US approval, USCG approval.
Yeah, thanks. Actually, that time when we installed the system, there was not even one system approved by USCG. Yeah. So yeah, thanks. Thank you.
Would any of the
I was just going to go back to the original question there, and regarding what happens if there isn't an extension. I think panic. I think that there's going to be panic and chaos, because it simply is not going to be possible to install the number of systems that will be required in the time frame that's available. We generally look at a 10-month project lifetime when it comes, or life cycle when it comes to ballast water treatment retrofits. From the initial meeting with the customer through to going on board, doing a survey, coming up with a concept design, then going into the detailed design process, and then the prefabrication and the installation. So already we're on the 19th of April. We've got less than 5 months before the entry into force. So it's going to be very, very difficult if there isn't an extension for owners to
I was just
comply.
going to say that, are we not very rapidly approaching a point where there is only one option, which is extension? AP Mulder is not going to shut down a whole container fleet because of this.
Well, I think when you say extension, you are not counting on the latest MEPC meeting. The latest MEPC meeting is to debate whether or not they will give an additional 2-year extension. The current way to obtain a so-called an extension or a pseudo extension in a way is to decouple the IOPP survey, to make it happen before the deadline so that you buy yourself another 5 years, which is the next IOPP survey, which you are then required to comply. So in the best case scenario in MEPC 71 taking place in July this year, they would give a 2-year extension in which they would then look at if your IOPP window ends up between now and 2 years later, you will only be required to comply on the second IOPP window. So virtually the additional extension that we are all hoping for would be maximum another 2 years. Otherwise, you would decouple your survey and get 5 years.
It will be 2 years plus 5, so total 7 years.
Provided MEPC 71 accepts the recommendation or chooses to accept the recommendation. MEPC 71 may decide to keep the original implementation date.
Will that not depend on the flag as well, as you mentioned earlier?
No. Flag means if it's considered under same risk area, that means yours is more like a restricted service vessel. It's not consistently engaged in international voyages.
You mentioned earlier some flags are allowing the decoupling and some aren't.
Yes, that is also correct.
Ocean-going vessels whose flag doesn't allow the decoupling. Then we are back to square one, isn't it?
That's an interesting question, but I assume that most flags would either have to agree or change flag.
Change flag.
Just to answer your question, now what is happening is that some flags have given blanket approval for decoupling the IOPP, and some are taking it case by case basis. So for some flags which are given blanket approval, there is no more, you don't have to contact them anymore. Other cases you have to contact the flag and get the approval.
I'm just wondering on a very specific case that there is a 20-year-old bulk carrier whose IOPP survey is due, let's say December 2017, and July 2017 is the MEPC 71 get-together, during which they decide, no, we stick with our plan, and IOPP surveys, you must renew your ballast water treatment system. And as Matthew has just said, it takes, what did I hear, 10 months? You earlier said between 4 and 6. So let's say, so you have about 2 or 3 months to decide. And even if you decide how, it's going to be, I wouldn't want to be in that person's shoes, that ship owner's shoes. So is it really coming, will it come to the stage where the ships will be stopped and said, no, you cannot trade until you fit this thing? That's going to be a little, sticky. And it's practical, right? What I say, it's not that, this is not theoretical. It's, I'm sure there are many ships afloat which will be in this position.
I'm not sure that so many flags are going to take such a tough stand. That we have seen, if there were already flags that are giving blanket exemption, I think generally most flags will make a special consideration, especially if you justify by means that this is like an existing vessel with so many years and possibly not going to work it for another 5 or 10 more years. Maybe at maximum 5 years, and after that you will have it scrapped or recycled and a new one in service. So it's really hard to say. We're not flag. We cannot decide on their behalf. But I think the dynamics of it itself would play out, and the owners would know what to do when the time comes.
Okay, one last question. Anybody?
I think my question is to Matthew about the treatment system itself. We are talking filtration probably, and we are talking treatment of seawater, more or less.
Sorry,
so I don't know if the ship is loading from a place X, right? Would it be easier to and better for the environment to have the water treated where the ship is docking at and where and therefore has a certificate and go with a certificate rather than having the filtration system?
I mean, I think it's too late actually for that. In that for ports to have the facility to provide that water in the volumes required, there's not enough time for them to put those systems into place. So the only way, as an industry, we had that option 10 years ago or 20 years ago when the ballast water treatment process was first being looked into. It's too late now for us to go down the route of utilising water treated in the reception facilities in the ports. It's only really onboard treatment that we can look at.
Yeah, theoretically, the U.S. administration, the U.S. state allows a vessel without a U.S. Coast Guard approved system to enter the U.S. waters if they don't discharge water into the U.S. port and instead discharges into a public system where they collect the water. So theoretically that is available, that option is available, but I don't think practically that's possible considering some of the large ballast volumes that are involved when say a big
All right,
tanker.
and the other question was about the treatment system itself. So we are talking like a filtration plant, basically, more or less on the barge, right?
No, a filter is part of all the treatment systems. Every ballast water treatment system that exists today does the treatment as a two-stage process. So all of them have a filter. That's the first stage anyway. It's the second stage wherein they kill the organisms. So that has different methods, either with a chemical or with a physical thing like a UV light. So the filter itself isn't able to filter out the very small organisms and kill them. So a filter alone would not serve the purpose.
Yeah, maybe I'll make myself clear. The treatment system, I mean. What are we treating? It's seawater, right? So what are the pollutants which are what are the pollutants that we intend to treat, like the major pollutants? What are we talking about?
Yeah, it's not actually pollutants. The Ballast Water Convention talks about invasive species. So the idea is that a natural organism which is not a resident of a particular area is not introduced there. For example, if I'm traveling from UAE to Houston, I should not pick up ballast water from UAE because it will have organisms that are typical of UAE waters and discharge those organisms in the Houston port. Because the idea is that every area has a balanced ecosystem. So every organism will have its own predator, which would prevent its concentration from increasing too high. The nature will have its own system. But for an organism in UAE, it would have a predator, but in Houston, when it's discharged, it wouldn't have any threat. So maybe you can have a scenario where it just multiplies and dominates the existing species of that area. So that's the concept.
All right, thank you.
One little silver lining to possible extension on ballast water is that we then get a clash between ballast water and the sulfur regulations. Sulfur regulations is, of course, another big cost to the industry. The cost of scrubbers is anywhere between $1.3 and $2.5 million per system That's before we take into account the engineering cost and the installation cost. But with scrubbers, there is actually a return on that investment. The installation of, there's obviously with the NOx requirements, the SOx requirements, there are really three routes to compliance. One is utilising of the low sulphur fuel. Second is to go with an alternative hybrid fuel, LNG or hybrid fuels. And third is to install an exhaust gas scrubber to clean the exhaust gases so that they're equivalent level. What that then means for the owners is that they can actually control their operational costs similar to what they have now. So the expected cost differential come 2020 between the current 3.5% sulfur fuels and the 0.5% fuels is about $200 per tonne. So if we look at a VLCC burning 70 tonnes of fuel a day over 280 days a year, that's around, I think it's about $3 million that they're not going to save. They're going to maintain it at the current levels, so they can avoid that additional expenditure in the future. Now, that can be coupled potentially with a ballast water treatment installation, because all of this kit needs to go somewhere. The engine room, steering gear room is the most likely place where that's going to go. So potentially owners can couple the two together as a capex and actually almost see a return on it.
Okay. Thank you very much, Simon, Matthew, and Naveen, for this very enlightening and informative session. And thank you all delegates who have made it lively. And now is the presentation time. I will request Mr. Y. Song, Deputy General Manager of CJ Logistics, who is our platinum sponsor, to come over to stage and present the mementos. First of all, I call upon Naveen Nair to accept the memento. Mr. Matthew Plumtree. Mr. Simon Shaw. Thank you, Mr. Song. Just join us for a photograph. Thank you. Now it is a time for a short tea break. Okay, we'll be back at 4 o'clock. Sharp 4 o'clock. Thank you.
Mastec 2017, the major sponsors. The platinum sponsor is CJ Logistics. We have got a cocktail reception sponsorship given by Blue Water Shipping. The gold sponsors are Blue Water Shipping, Floor, McDermott, Technomac, ABS, and our registration desk is sponsored by Aris. Lanyard is by Great Waters. And our associate sponsors are Chalmers, Albowadi Marine, Class NK, Hempel. And we are also supported by organizations like Indo Maritime, EduBrisk, Noble Oceanus, ACMT, YMC, ASTS, Blazer Marine. Thanks.
of integrated global market. Supply chain system optimization is the key to increase company competitiveness. Now, we take a big stride forward with one-stop solution based on the worldwide global network and a cutting-edge system. The global SCM innovator, CJ Logistics. CJ, a global lifestyle company, leads the lifestyle of people all over the world. Food and food service, bio and pharma, logistics and retail, and entertainment and media. CJ Group creates the culture of cosmopolitan people in 4 major areas. CJ Logistics, the key engine of CJ Group and the leader of global logistics innovation, takes the lead with our customers at all times. With countries including the US, China, and Southeast Asia. Our logistical territory further expands with its worldwide network. CJ Logistics, with its TES-based advanced logistics technology, rich know-how on supply chain operation, and IT solution, has established one-stop logistics service optimized for each customer. TES, the key competence of CJ Logistics, quickly responds to the changing logistics market to create the new logistics paradigm. State-of-the-art and future logistics technologies, such as convergence robotics and intelligence technology. Engineering that optimizes for the entire supply chain. System and solution based on IoT technology. Smart technology and consulting with expertise, presenting an optimized solution for customers in various sectors. This is the globally recognized competitiveness of CJ Logistics. CJ Logistics established a one-stop solution for the entire logistics field. Industry group-specific sales know-how and cutting-edge IT solutions. Total service of contract logistics. Based on the huge-scale domestic, overseas infrastructure and directly operated system, stable services are provided. #1 market share and customer satisfaction in South Korea. The company realizes #1 parcel service. From imports and exports of marine air transportation to customer clearance and storage. With diverse stevedoring equipment and facilities, CJ Logistics provides optimal marine cargo stevedoring and transportation service. Based on diverse EPC equipment and transportation know-how, CJ Logistics Project Logistics provides a stable logistics service for domestic, overseas plant, special, and break bulk cargoes. CJ Logistics always stays as a reliable global partner to customers. CJ Logistics has the whole world as a stage. CJ Logistics is broadening its market across the world with a global logistical network. Our one-stop solution will always be with customers.
We are the best, CJ.
The global SCM innovator, CJ Logistics.
Blue Water Shipping is a worldwide specialist in project freight forwarding. And with more than 40 years of experience, Blue Water is the right team for any major project transport. The job in this project, to transport a massive lower hull and heavy topside components for a drilling rig from Asia to South America. The company's Singapore office is in charge of the challenging project that involves strong teamwork with the client, external partners, and other Blue Water offices.
Out here we are not only a freight forwarder, we are a very dedicated project freight forwarder that likes to handle complicated stuff. We did the groundwork for this project approximately 2 years ago, and we did a lot of studies back and forth, not only on a commercial level but also on an engineering level, because the cargo specifications are obviously very complex, and we have to be very thorough and have to provide our client with proper solutions.
The debut of the project brings us to Batangas, Philippines. It's here where today the future oil rig's massive pontoons will be loaded. Blue Water Shipping is responsible for the complete wet towage from the yard onto the semi-submersible vessel and the delivery of the pontoons to Singapore. Carefully, the tugs maneuver the steel colossus above the deck of the Casco XRK. Once in place, the water is blasted out of the ship's 61 ballast tanks, and both pontoons rest safely on the dry floor. The ship now sets sail to Singapore to deliver its expected cargo. The first stage of the project is successfully accomplished. The two pontoons will now be used to create the lower hull, the massive base structure that the future oil rig will be sitting on. 4 special tugs connect their pulling lines to the lower hull. The Blue Water team keeps a watchful eye on the operation. Slowly and precisely, the giant structure is maneuvered towards the Vanguard's deck. Meter by meter, inch by inch. Everything goes as planned. It's a major success. And finally, the lower hull is perfectly floated onto the Vanguard. Shortly after the Vanguard's departure from Singapore, the project's next phase commences: the lifting and transport of the oil rig's topside components. All heavyweight champions in their class that require complex engineering to ensure a smooth and safe delivery. Carefully, the large structures are lifted onto the vessel. It's a team effort and shows once more Blue Water Shipping's veteran experience in applying tailor-made logistics to the oil and gas industry. Precisely, in record time, with 0 incidents, and to the customer's fullest satisfaction. Finally, Hercules places the derrick tower accurately on its pre-calculated position. The ship has to travel 8,800 miles through the Indian Ocean, rounding the Cape of Good Hope, and then crossing the vast Atlantic Ocean to finally reach Angra das Reis, where just now, the Dockwise Vanguard is about to complete her journey. On her way, she had to deviate away from 2 tropical storms and battle unfavorable currents. But now, she's here. It's a magic light welcoming a mighty ship. The pilot gets on board to navigate the Vanguard to her float-off position. Only an hour later, the gigantic lower hull structure floats off the deck. Delivered on time and without a scratch, it's a major milestone in accomplishing the project. Shortly after the delivery of the lower hull, the pilot station at Angra dos Reis receives a call from Combi Dock 3. Her captain reports she's on her final approach and ready to enter the bay. With 14